Dear colleagues, it's a pleasure to welcome you to the EAI International Conference on Computer Science and Engineering in Health Service. The previous editions, held in Malaysia, Thailand, and Mexico, had been a success with a large participation of authors attending as well as keynote speakers. This year, the conference was planned to be held in Mexico City, but due to the pandemic, it will be held virtually. But with all the enthusiasm, we know that this edition of COMPSE will be a success thanks to your participation. This year, in the keynote conference, we will have the participation of Professor Tatyana Romanova, an expert in optimization, who will address some applications of the phi-function technique in additive manufacturing. This year, we received a large number of papers on various topics, like computer science, optimization, health systems, and in this occasion, we integrate a workshop track on explainable artificial intelligence in health application, from which we received a very good response. I would like to thank the European Alliance for Innovation for all their support in organizing this conference, as well as the steering committee, organizing committee, and technical program committee. No more than ever, it is necessary to promote and develop high-quality research to address global problems. We hope you enjoy and take advantage of this forum for dissemination of knowledge and joint work. Again, welcome to COMPSE conference.
Ladies and gentlemen, welcome to the 4th EAI International Conference on Computer Science and Engineering in Health Services. I am Natasha Onofre, the conference manager of this year's edition. Unfortunately, due to the pandemic, I'm not able to meet all of you in person, so I'm taking this opportunity to address the organizing committee, the authors, and our online audience on behalf of the European Alliance for Innovation. Above all, I would like to express my gratitude to the General Chair José Antonio Marmoleo and the Program Chair Hania Saucedo for their excellent work in organizing a successful conference in these difficult times. As you know, EAI COMPSE is an annual conference, and I would like to invite all of you to participate in our 2021 edition by submitting your papers, by organizing a workshop, or by joining the Technical Program Committee. In fact, at EAI we're constantly searching to promote innovative research in the field of information and communication technologies. So if you have an idea for a conference or a workshop, or you would like to collaborate with us in any other way, please don't hesitate to contact me at the email address below. During this streaming, you can actively participate in two ways. Firstly, you can take part in the Q&A discussion on Slack by following the link below this video. Secondly, you can vote on individual presentations and leave your fellow researchers feedback on their work through our tool, EAI Compass. In a few moments, my colleague Michal will tell you more about the EAI entity, the tools we provide, and the aforementioned voting process, which you can already use during today's event. Thank you all for your attention, and I hope to be able to welcome you again next year. Enjoy the conference!
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier, and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI COMPSE, Community Review, and EAI Index. Firstly, EAI COMPSE is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI COMPSE website, compse.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work-in-progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI COMPSE to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Dear colleagues, allow me to present the basic foundations of the phi-function technique and its applications in additive manufacturing. The phi-function technique is a generic approach beyond and within mathematical programming very suitable for solving large-scale real-world layout, packing and cutting problems. Common to additive manufacturing technologies is the use of a computer, 3D modeling software, computer-aided design or CAD, 3D printer, and layering material. In additive manufacturing technologies, designing smart 3D models for printing parts plays a key role in the overall manufacturing process. Three classes of optimization problems related to additive manufacturing are considered. The first problem is referred to as a generating void structures. Additive manufacturing offers enormous geometrical freedom to create parts. Creating hollowing systems is a typical practice for reducing printing material and time in 3D printing of light-weighted parts. Generating void structures can also be interpreted as a layout problem with holes stand for allocation of items. Number of holes, their shapes and sizes, positions and space orientations have to be defined, minimizing the weight of the part without significant loss of its mechanical strength. The second problem concerns preparing material used for printing. Laser 3D printers can work with various materials, including metal powders. There are two main approaches for manufacturing parts using 3D printing: fixation, alloying, or sintering of powder in the previously applied layer and direct layer-by-layer application of the already melted powder onto the substrate. In both cases, pores may arise that are difficult to eliminate. The quality of the powder is related to its packing density depending on the powder particles' composition, their sizes, and shapes. This way a layout problem corresponding to the densest layer filling arises. The third problem is referred to as a build volume packing. As a parallel manufacturing process, 3D printing enables manufacturing different parts in a single build volume. Thus, a problem of optimal layout of different parts in the build volume arises. A set of 3D parts must be placed into the build volume optimizing a certain objective. The items have to be distant enough from each other to prevent from deformation while cooling after layer-by-layer process. All the problems mentioned above belong to a broad class of 3D optimization layout problems. In its most general form, a set of volumetric objects has to be allocated inside a 3D domain and optimizing a certain objective subject to additional specific constraints, including continuous object rotations and translations, allowable distances between objects, allowable metrical characteristics of objects, prohibited zones. The methodology to address each of the problems stated above consists of four main phases: modeling and development of theoretical properties, designing and studying solution techniques, computational implementation, designing prototypes. The central point in modeling layout, or packing problems, is an analytical description of placement conditions of 3D objects inside the given domain regarding 3D printing standards. We will use the phi-function technique that allows us to formulate the optimization layout problem of irregular shaped objects in the form of non-convex nonlinear programming problem. Based on the results obtained in Phase 1, this stage is dedicated to appropriate solution techniques. The fact that packing problems are classified as NP-hard combined with large dimensions of instances, makes developing solution methods a challenge. Once a solution technique has been designed and developed, the computational implementation phase is entered. Available NLP solvers can be used as a part of the implementation. Let us introduce basic foundations of the phi-function technique and demonstrate practical benefits of this tool that is successfully used in solving practical layout, packing and cutting problems. Phi-functions can be described by quite simple formulas. Conceptually, the phi-function technique exploits NLP and MNLP and can be understood as layout problems beyond and within mathematical programming. In spite of different applications, most of the optimization problems can be formulated in the following way. A collection of objects of different 2D or 3D shapes are considered. These objects can be continuously translated and rotated in 2 or 3-dimensional space. Each object has variable motion vector. A 2D target domain is bounded by arcs and line segments. A 3D container is bounded by spherical, cylindrical surfaces and hyperplanes. Geometric constraints provide allowable distance between objects, feasible positioning and orientation of objects, prohibited areas, or defected zones. Mechanical requirements concern the overall center of mass and the axial or centrifugal moments of inertia. The basic layout problem can be formulated as the following optimization problem. Let n be the number of geometric objects to be packed and let omega be a container. The objective is to pack the collection of objects into the container, taking into account geometric and mechanical constraints, such that a given objective function will reach its extremum value. The geometric constraints involve non-overlapping, containment and distance constraints. The phi-function technique is aimed to describe the geometric constraints analytically. In solving the layout problems, it is very important to distinguish between different types of mutual location of two objects, including non-overlapping, touching and interior intersecting. Note that the containment is conveniently described by non-intersection of the interiors of the placement object and the complement to the container. The basic mathematical idea is that for any pair of objects the phi function must be positive for non-intersecting objects, 0 for touching objects, and negative for objects with intersecting interiors. Phi functions in their positive mood serve two purposes: keeping objects apart and keeping objects into a target container. The concept of quasi-phi functions extends the phi function domain by introducing auxiliary variables. The use of quasi-phi functions, as an alternative to phi functions, allows for simplified descriptions of placement constraints, at the expense of a larger number of variables. Some applications involve explicit restrictions on the allowable distances between certain pairs of objects, or between the objects and the walls of the container. Some upper and lower limits on those distances may be set. To formalize the distance constraints, an adjusted phi function, or adjusted quasi-phi function is used. The construction of phi functions is flexible. The advantage of this fact is taken to develop more efficient algorithms. While the construction of phi functions may be elaborate, it only needs to be done once for every pair of objects. In any layout or packing problem with known shapes of available objects, one can prepare a set of properly defined phi functions for the use by optimization algorithms. The phi functions can be stored in advance, offline, in a library, and then each instance of the problem can be solved quickly by calling the ready-to-use phi functions from that library. In terms of phi functions, the layout problem can be formulated as a constrained optimization problem suitable to be solved by general methods of mathematical programming. For each object, a vector of its variable parameters is defined. These may include the translation vector, the rotation angles, some metric dimensions if those are not fixed. The feasible region is described by a system of constraints concerning metrical characteristics of the container and placement parameters of objects. Also, it involves a system of mechanical constraints. The multiplicity of shapes of objects and containers, as well as the variety of restrictions and forms of the objective function, generate a wide spectrum of realizations of this basic problem. We propose a unified solution strategy with the ultimate goal of designing efficient algorithms for solving these optimization problems. The multi-start strategy consists of 3 main stages. Stage 1. Generate a set of feasible starting points. Stage 2. Search for a local optimal solution of the problem for each starting point found at stage 1. Stage 3. Choose the best local extremum from those found at stage 2. The actual search for a local minimum is performed by NLP solvers. To generate feasible starting point, we use algorithms based on homothetic transformation of objects, grid-based algorithms, and algorithms that are based on epsilon strip approximations. For local optimization, we employ decomposition algorithms, Shor's algorithm, and accelerated search. Let us consider applications of the phi-function technique to the layout or packing problems arising in additive manufacturing. The first problem we are talking about is generating void structures. The problem is motivated by designing parts with complex geometry for their production using 3D printing. Additive manufacturing is widely used to produce lightweight parts. It can be challenging to prepare the optimized topology as a final CAD model for 3D printing. We discuss here the approach to design topologically optimized parts with the support-free structures. The approach is based on the optimal ellipse layout problem and can take into account the 3D printing restrictions. The popular approach implies inserting in the part geometry, so-called supports, at the pre-manufacturing stage. The supports then have to be removed, thus increasing duration and cost of production. The lightweight and support-free technologies are free from these disadvantages. The part generated using the lightweight and support-free design has sharp changes in the shape. They represent the stress concentrators that cause local increases in mechanical stress. We propose an alternative approach to design the support-free structures. The approach deals with the cylindrical holes integration in material-free spaces of parts. We discuss here a problem of the optimal layout of ellipses that takes into account special technical requirements of 3D printing, including item minimum wall thickness and item minimum and maximum radius of curvature of the internal surfaces. Let omega be a disconnected polygonal region with convex connected components. A family of ellipses with variable semi-axes is given. Each ellipse can be continuously translated and rotated. In addition, a minimum allowable distance between each pair of the ellipses is defined. Ellipse packing problem in a disconnected polygonal domain can be stated as the following layout problem. Find such ellipse subsets that can be fully arranged within the appropriate convex polygons, with the maximum occupied area taking into account the given minimum allowable distance between the ellipses. The problem is equivalent to a sequence of n independent layout subproblems of layout ellipses in each convex polygonal component with maximum packing factor. In the layout problem, the containment and distance constraints are met. For analytical description of the containment constraint of the original problem, we define a phi-function for an ellipse and the complement to the disconnected polygonal domain omega. To formalize the containment constraint for the EPC problem, we define a phi-function for an ellipse and the complement to the convex component of the domain. The non-negative values of the phi-function provides the belonging ellipse to the polygonal region. The normalized quasi-phi function of continuously rotated and translated ellipses of variable sizes is defined. This function is responsible for describing the distance constraints. Now the optimization layout problem of ellipses in disconnected domain can be formulated in the form of the mixed I-integer problem. The problem is equivalent to n independent sub-problems of packing ellipses in convex components of the domain. We develop special algorithm that solves the ellipse layout problem and allows finding the number of descending ellipses, their optimal sizes and placement parameters, taking into account minimum allowable distances between ellipses. Then we apply our algorithm to design a geometry of a part for the support-free 3D printing. This geometry is the result of the topology optimization applied for the 3D part, which is rigidly fixed at its end and loaded in the lower part of the opposite side with the load. Direct 3D printing of the given part using, in particular, direct metal laser sintering, leads to unexpected printing results. To exclude such cases, support and support-free models have been designed. Stress state of the parts made of the aluminum powder were investigated, including cases without support structure, with support structure created by Materialize Magics and structure suggested in Leary 2014. Manufactured parts with such structures are shown in the picture. An alternative geometry can be built by our algorithm. The area omega involves 5 disjoint convex polygons. We designed 2 parts with elliptical holes and with round holes. Then we analyze mechanical stress of the parts. The average level of mechanical stress is much smaller than that in the previous models. In addition, the suggested algorithm for preparing parts geometry for direct 3D printing is not sensitive to the printing direction. The post-processing is done on a precision grinding machine and by drilling the circular holes. Minimum post-process effort is necessary and the fatigue strength of the part can be improved. The proposed approach allows obtaining part with the optimized topology, which is ready to use for direct manufacturing using the technology of the support-free 3D printing. The resulting geometry of the part is not sensitive to the direction of 3D printing, does not have stress concentrators in comparison with alternative approaches, does not require post-processing. The developed program automatically creates designing parts according to the criteria of both static and fatigue strength. The second layout problem we discuss here is densest layer filling. In additive manufacturing, a layer-by-layer build-up process is used for manufacturing parts. Modern laser 3D printers can work with various materials including metal powders. In particular, mixing various sized spherical powders of titanium alloys is considered most promising for the aerospace industry. To achieve desired mechanical properties of the final product, it is necessary maintaining a certain proportional ratio between different powder fractions. In this research, a modeling approach for filling up a rectangular 3D volume by unequal spheres in a layer-by-layer manner is proposed. The objective of this research is to develop a modeling approach for filling up a rectangular 3D volume by unequal spherical powder particles in a layer-by-layer manner. A relative number of spheres of a given radius or relative frequency is defined and has to be fulfilled in the final packing. Fast algorithm has been developed to solve this special spherical packing problem. Numerical results are compared with experimental findings for titanium alloy spherical powders. The relative frequencies obtained by the algorithm are very close to those obtained by the experiment. Thus, an opportunity to use a cheap numerical modeling instead of expensive experimental study is outlined. We consider the layout problem in the following formulation. Let omega be a cuboid of given dimensions. Also, let m types of spheres with the appropriate radii be given. The number of spheres to be fully packed into the cuboid is not known a priori, so let be an upper bound for that number. Our objective is to simulate filling up the cuboid by spheres by pouring them naturally into the cuboid and calculate the packing factor. Moreover, relative frequencies of the appearance of the appropriate radii among all spheres in the cuboid are given. We propose a fast algorithm to simulate filling up a cuboidal domain by mixtures of spherical particles having a given particle sizes distribution. The key idea of the algorithm is as follows. Placing new spheres and checking non-overlapping with previously placed spheres are carried out only in the so-called active layer. The thickness of the active layer is dynamically adjusted in the iterative procedure according to the original data. This reduces significantly the computational time required to simulate filling up the volume by mixtures of spherical particles. In real-life applications, the correspondence between the size of the cuboid and radii of the spheres is defined in such a way that a huge number of spheres is required to fill up the cuboid. Bearing in mind additive manufacturing, all sphere packing operations have to be performed within the upper layer of the cuboid having a variable width delta. In what follows, we refer to this layer as an active layer. Our algorithm is an iterative procedure to simulate the natural process of pouring a mixture of different types of spheres into a cuboid. For non-overlapping and containment constraints, we use the phi-function technique. A sequence of sub-problems corresponding to 1-by-1 random arrangement of spheres in the active layer is solved. At each iteration of the procedure, parameters of the active layer are updated. The algorithm involves 7 main steps. Step 1. Normalize the sizes of objects, radii of spheres and dimensions of cuboid. Step 2. Form the vector P. Step 3. Generate sizes and placement parameters of the first sphere. Step 4. Generate sizes of the I-sphere. Step 5. Generate the packing of the I-sphere. Step 6. Get the minimum z-coordinate of the I-sphere, solving the nonlinear programming sub-problem. Starting from the point found at the previous step. The optimal solution of the nonlinear programming problem provides coordinates of the center of the I-sphere. Step 7. Recalculate the active layer parameters. Illustration to the recalculating the active layer parameters is provided in the figure. Step 8. Restore the original sizes of the spheres and the cuboid, and also recalculate the corresponding coordinates of the sphere centers. Step 9. Remove all the spheres that cannot be packed into the cuboid. Our basic results include experimental and computational parts. The preliminary distribution of the powder was carried out using the sieve method. The metallographic studies of the powder morphology were performed using scanning electron microscope. The test sample was thoroughly mixed on sheet glass, poured in a stripe of a certain length and divided into 7 to 8 approximately equal parts. The even parts were not used and the odd ones were mixed. The process being repeated several times. Next, a powder sample was applied to an electrically conductive adhesive tape and examined at 50 and 100-fold magnification. The particle size analysis was performed on the ImageJ specialized image analysis system. The degree of the powder heterogeneity, polydispersity, was determined by the method of constructing a Gauss curve. The studies were conducted for titanium alloy powders with particle sizes ranged from 200 to 1000 microns. The powder fractions were obtained by the sieve method, characterized by a small scatter of particles in size. The results of the metallographic analysis revealed that after centrifugal plasma spraying, the powder particles have defect-free globular shapes and a small discrepancy in size shown in the figure. An analysis of microstructure images made it possible to obtain a spectrum of the average powder particle diameters of titanium alloy powder particles after spheroidization for 4 powder fractions. Gauss curves are constructed and the value of the polydispersity of the powder particles of the studied fractions is calculated. This allowed us to obtain a quantitative and percentage size distribution of spherical particles in each of the fractions using the image fragments. The obtained polydispersity values indicate that the studied powder fractions are quite homogeneous and can be used for the 3D printing process. Let us consider the computational results related to the packing problem. We consider cuboid of sizes motivated by the dimensions of the 3D printer chamber. In each example we calculate the porosity of the composite, that is the inverse value to the packing factor. Using the proposed algorithm for optimized packing of titanium spherical powder particles, we may conclude that the built-up layers of titanium alloy spherical powders of fraction 4 have the best micromechanical properties. Our results were compared with those obtained by neural network modeling and with studies of the bulk density of the packing particles of titanium alloy powders. It was found that the relative frequencies obtained by the algorithm are very close to those obtained by the experiment. The difference is less than 2%. The results obtained are reliable and the proposed approach can be used for estimating the packing density of powders having various fractional compositions. This provides an opportunity for using a cheap numerical modeling instead of expensive experimental study. Let us formulate some concluding remarks. The size of fractions of titanium alloy spherical powders is critical in reducing the number of defects in built-up layers. Filling the pores in concrete with solid materials or nanoparticles improves the strength significantly. The main contributions of the research are as follows. A problem of packing spheres into a cuboid is formulated taking into account statistical probabilities of the appearance of different spheres. A fast algorithm combining an active layer heuristic strategy and nonlinear optimization is proposed. A technique is developed for simulating the process of filling up a given volume by mixtures of spherical particles having a given law of particle sizes distribution. It is a common belief that in 3D printing a spherical form of powder particles provides better results comparing with other shapes. However, to manufacture spherical powder materials, sophisticated and expensive technologies are used, thus resulting in high production cost. Therefore, it is interesting to study the possibility of using native raw powders of titanium alloys of the non-spherical shapes that undergo hydrogenation and dehydrogenation. From algorithmic point of view, this approach requires mathematical models and techniques for packing non-spherical particles, for example polytopes or ellipsoids. An interesting direction for the future research is adapting the existing approaches and techniques for packing irregular 3D objects. Modeling techniques proposed in the research can also be used to design the microstructure of composite and functional materials with predefined operational properties. Build volume packing. The third problem we discuss here related to build volume packing. It is actual problem arising in 3D printing to maximize value of products that can be produced at the same time. We consider the problem of packing polyhedra in the following setting. Let a collection of polyhedra be given. Each polyhedron can be continuously rotated and translated. As a container, a cuboid of variable sizes is considered. The following restrictions must be satisfied. Containment polyhedra into the container. And minimum allowable Euclidean distances between each pair of polyhedra. The objective is to pack the set of polyhedra within a cuboid of minimum volume taking into account the given minimum allowable distances. In order to construct mathematical model of the layout problem, we define adjusted phi-function for analytical description of the distance constraint between polyhedra. An adjusted phi-function for a polyhedron and the complement to the container for the containment constraint. Now mathematical model of the packing problem can be presented in the form of nonlinear programming model, where feasible region is described by the phi inequalities with differentiable functions. Our model is a non-convex and continuous nonlinear programming problem and an exact formulation for the polyhedron packing problem. The model involves n-square nonlinear inequalities and variables due to auxiliary variables in quasi-phi functions. As a result, even finding a locally optimal solution becomes a complicated task for the available state-of-the-art NLP solvers. Our multi-start solution strategy involves the following steps. Generate a set of vectors feasible placement parameters of polyhedra placed into the container omega of sufficiently large sizes. Search for a local minimum of the layout problem, starting from each point of the set of feasible points obtained at step 1. Choose the best local minimum from those found at step 2 as the final solution of the original problem. We develop special algorithm that returns the vector of placement parameters to generate a starting feasible point for a subsequent search for a local minimum of the layout problem. For local optimization, we propose a compaction algorithm. This algorithm allows us to reduce the large-scale layout problem to a sequence of sub-problems with a considerably smaller number of inequalities and variables that is linear to the number of polyhedra. The diagram of the optimization procedure presents 3 iterations. At each iteration, the NLP sub-problem is solved. The obtained local minimum is taken as a starting point for the next iteration. At the last iteration, the local minimum of the original problem is found. Arrangements of non-convex polyhedra corresponding to the sequence of feasible points with respect to the diagram are shown in the picture. To show the efficiency of our algorithm, we provide the results of some computational experiments. Feasible and optimized arrangement of convex polyhedra. Feasible and optimized arrangement of non-convex polyhedra. Local optimal layout of convex polyhedra with minimum allowable distances. Local optimal layout of non-convex polyhedra with minimum allowable distances. We complete our examples with the best solutions for 2 benchmark instances.
Welcome to this talk. My name is Leonardo Gabriel, and I'm going to present to you a work that we carry out in collaboration with a service company. The title of my talk is Classification and Clustering of Clients of a company dedicated to the distribution of auto parts in the metropolitan area of Monterrey. My co-authors are Rosalena Mata Martinez, Argelia Vargas Moreno, and Arlet Yari Garcia Aguilar. We are part of the Department of Industrial Engineering from the Faculty of Chemical Science in Universidad Autónoma de Nuevo León. This study was conducted in a company dedicated to the sale and distribution of automotive parts. This company has positioned itself in the domestic market with 11 branches strategically located in Culiacán, Guadalajara, Mexico City, Mérida, Monterrey, Puebla, Villahermosa, Tampico, Toluca, and León, Guanajuato. This company is one of the most important auto parts wholesalers in Mexico, serving more than 7,000 automotive parts stores throughout the country. We can see on the map the location of the company's distribution center. The point in the north is the distribution center in which we will focus this work. In the city, this company is one of the main wholesalers, and they are looking to consolidate as the biggest supplier of the city based on the group strategy. Their delivery is made employing different types of fleet. They have pickup trucks, motorcycles, and cars that distribute throughout the Monterrey metropolitan area. One of the main objectives of this company is to define the best distribution alternative that will improve delivery times and take advantage of the resource that they have. Currently, this company lacks an adequate distribution system. Its distribution process is more empirical and based on the skills of the staff and years of experience. Main project process. The project has three main stages, which are listed below, and the process is detailed. First stage, analysis of the current state of the distribution system and classification of customers. This first stage is the one that is developed and shown in this research work, combining different clustering technique analysis. The second stage is the analysis of distribution alternative and the development of distribution algorithms, creating a more efficient route generation system to take advantage of the company resource. Third stage, control and improvement. This is the step where a complete system is implemented. The necessary validation and adjustment are made so that it works in an integral way. Finally, monitoring and control continue. Analysis of the current state of service. The Monterrey branch currently has a portfolio of approximately 400 clients, of which more than 250 have regular activity. Most of the clients' activities are not constant, however, the recurring clients are frequent. As we can see in the graph, the 10 clients with the highest participation represent the 32.4% of the total activity. The 20 most frequent clients represent the 45% of the activity, and the 50 most frequent clients represent the 63% of the total activity. In the graph, we can see that the main clients represent over 50% of the sales. However, the company has stated that the level of service and delivery times must be the same for all clients. Actual process. The actual process begins with the generation of a purchase order from the customer with the products they need. Then, the stock of the product is checked in the system. If it is in the stock, the purchase order is based on the warehouse department to picking up the product. The order invoice is generated once the product is released. It is assigned to a driver for distribution along with other purchase orders. The driver makes its own route and finally is delivered to the customer. Classification and clustering. A collection of the precise geospatial information of the customer was made in order to analyze their location and visualize the distribution around the city. Figure shows only the main customers distributed throughout the city of Monterrey and its metropolitan area. We can see that clients are distributed throughout the city, with some small groups. This makes it a difficult task to be able to classify them in a simple way. Heat map. At first glance, the density of the client's concentration is not noticeable in the last map. Since the concentration of the dots is lost in the dotted display, then a heat map of the concentration of customers in the city and its metropolitan area is displayed. Purple represents lower density and green represents higher density. We can observe two main areas, in the center of Monterrey and in the San Nicolas area, as the places where the concentration of clients is highest. It is interesting to observe how the centers of the municipalities of the metropolitan area are the areas with the highest concentration of clients. Clustering. The method described in the referred paper, where key representative objects called medoids selected from the dataset are searched for and can serve as prototypes for the group inside of the means allowed to use the other arbitrary dissimilarities and arbitrary input domains. Using the absolute error criterion, that is the total deviation as target, as we can see in the next equation, which is the sum of the dissimilarities of each point x in the cost of the medoid of each cluster. If we use the Euclidean square distance function, we almost get the usual sum of squares target used by key means, except that chi-mediate is free to choose any mu in the real number, while the k-median m in the cost must be one of the original data points. At this point, we calculate a new parameter for each customer, which involves the average weekly order volume determined by the y view, and being adjusted to a logarithmic scale as a way to smoothing the parameter. This is in order to fit into the cost of calculating distances of the medoid. For distance L1, also called Manhattan distance, the median of the components is a better choice. The medoid of a C set is defined as the object with the smallest sum of difference, or equivalent to the smallest average, from all other objects in the set. This is the equation for the medoid of C. The partition around medoid PAM algorithm consists of two phases, one of the construction and another of the improvement by means of a change that optimizes the grouping. It should be noted that this algorithm works in OK. For this article, we consider the performance measures average silhouette with ASW and index CH. ASW and CH attempt to balance a small within cluster heterogeneity, which increases, and a less between cluster heterogeneity, which increases with the K as well, in a supposedly optimal way. Results. The clustering algorithm is executed on a computer with an Intel Core i5 processor with 6 GB of RAM. The development of cleaning, selection, and classification algorithm was designed in R language, creating a variation of clustering scenarios of the customer to verify the sensitivity of the algorithm to reclassify the groups in case of fleet size change for the generation of a new clustering strategy. Instances from 4 clusters up to 20 clusters were executed in order to analyze the different alternatives and reach a conclusion on how many clusters for the client classification were necessary. In the next slide, we will see a table of the comparison of the two metrics that were used in this work. In this table, we can see that the optimal number of clusters are between 9 and 13 clusters according to the average silhouette width and CH metrics. It can be seen how the QSMR are better distributed with the CH metric in the range of the 11 to 13, and the optimal number of clusters for the average silhouette width metric is 9. The company has decided to use 11 zones to classify QSMR to make better use of its resource, which is the subtablet within the result obtained in the table. Sample of client clustering. We can see in this image how customers have been grouped in such a way that both geospatial location and sales volume are used. There are clusters where we can observe some areas much smaller than others, but which are balanced according to the number of clients and the volume of their sales. For example, the Santa Catarina area in the lower left part of the map was created very separate from other areas, while in the Monterrey area located in the center of the map, around 5 areas were generated. Some municipalities share areas, such is the case of Apodaca with the municipality of Guadalupe, due to the low density of clients in the area, as we can see on the right side of the map. Discussion and further work. After the analysis, a methodology was established for the classification and grouping of clients for stage 1 of the project. The final document provided to the company is a database supported with Google Maps, so they can manipulate the details of each client and create a better routing. The result will speed up the process of route generation and distribution of products in order to reduce the routing time. In the same way, this classification will allow the generation of optimal routes for distribution units. Since a lower sectorization will allow to speed up the route search algorithms when considering a small group of customers. For the second stage, we will apply heuristic routing algorithms to take advantage of this classification made for the company. Well, finally, we want to thank to the Faculty of Chemical Science, the company, and the product program for their support in carrying out this project. These are some references of the work that we consult in literature.
Good day, everybody. Thank you for taking the time of being in this virtual conference to discuss a topic that contributes to climate change mitigation from a financial point of view. My name is Tatyana Romanova from Mexico, and I will present to you our proposal for a guide for sustainable project analysis to improve energy efficiency of Mexican small and medium enterprises. This work was developed with the collaboration of my co-author, Dr. Roman Rodriguez, who I thank for all his support. I present to you the structure of the presentation. We will start with the introduction and problem description, then continue to explain the methodology used to find a solution for the problem. After that, I will share the results of our approach, and finally, I will present our conclusions and recommendations. The SMEs are commonly called the backbone of the Mexican economy, since there are about 4 million companies. They employ 72% of the total workforce and contribute 52% of the country's gross domestic product. But likewise, the main source of electricity for these SMEs is generation by burning hydrocarbons, which generates enormous amounts of greenhouse gases. SMEs are responsible for 17% of the country's total energy consumption, both electrical and thermal energy, and 12% of the greenhouse gas emissions generated in Mexico, with a potential total reduction of close to 7 million tons of carbon dioxide equivalent emissions per year. From an economic perspective, sustainable projects allow SMEs to generate economic savings in energy consumption. Additionally, companies improve their competitiveness by implementing sustainable actions that enable low-cost production. Thus, in recent years, the Mexican government has launched programs focused on energy efficiency measures in SMEs and aim to mitigate the effects of climate change and seek to reduce the current demand for fossil fuel electricity production in Mexico. However, these type of programs have not the expected impact because there is a main obstacle to measuring their true impact due to the only metric in which the results of these projects are evaluated in SMEs is true profitability, since the financial institutions, mainly banks, do great management. The way in which sustainable projects are currently being evaluated is not efficient enough because positive or negative impact evidence is not extracted and documented. Hence, there is no information available that demonstrates the comprehensive benefits of their implementations. If data were available, the number of prospects will increase drastically in domino effect, given demonstrated potential demand, and international resources for this purpose could be accessed, which in turn will improve the financial conditions, ultimately making the projects more profitability and attractive, which is enough motivation to entrepreneurs, business owners, and financial institutions. Given that SMEs represent an important consumer of electricity in the country and actively demand resources associated with hydrocarbons, it is necessary to pay attention to the mitigation efforts carried out in this sector. Traditionally, projects that require financing from banks are analyzed under the net present value approach, which consists of determining the current value of the project, considering the cash flow generated in the future, apply inflation by using a discount rate, usually the interest rate or weighted average cost of capital, at which the initial investment equity of debt will be obtained. This method is used in project finance practices to determine the added value to shareholders, but it has a deficiency. It does not consider possible changes to the project during its useful life, which could represent maximizing profits or reducing losses. The cost-effectiveness evaluation model is an economy analysis that compares the cost incurred in the implemented projects against their results, assigning a monetary value to their consequences. This evaluation model is useful for social and environmental projects, where the impacts do not have an economy value by themselves, but their effects are beneficial for the population and the economy in general. When there are several projects that generate benefits, the cost-effectiveness analysis will allow an ordered classification of a relationship between the cost incurred and the effectiveness of the project. For this, the incremental cost-effectiveness is used by means of which the costs and effects of the different alternatives are compared, expressed in the same units. The cost-effectiveness plan, see please figure number 1, allows you to place the options according to their cost and the level of effectiveness. Ideally, the best option is to locate the best project in the second quadrant, where the option is most effective and less expensive. Real options are a financial instrument that provides the opportunity to make future modifications to a productive project to maximize its value. This tool is useful in sustainable projects due to the high level of uncertainty they have, caused by changes that may occur in the face of technological innovations, price changes, and therefore adjustments in the value and profitability of the project that could increase profitability over its operational life. Real options allow the investors to make decisions during the life of the project, which add future value and cut losses that a project could incur. With this tool, various actions related to the project can be carried out, like expansion, growth, contraction, or flexibility. The investor can change some characteristics of the project during its life, continually maximizing its value. The real options are the result of questioning the traditional method of financial evaluation of a project, where the project is not considered as a static situation. With real options, you can calculate future cash flow, incorporating the uncertainty from their volatility. To determine the effectiveness and profitability of a project based on real options, it is necessary to determine some variables that describe the particularities of the project, which will allow the construction of the model. Some of these variables are inflation, discount rate, volatility, but you have to put attention at the proportion of up and down. That is the proportion that could increase or decrease the value of the underlying asset, and with this you can calculate upside and downside probability that you will use in the model. The real options method offers to the traditional evaluation of energy efficiency projects the possibility of determining the present value of future cash flow under condition of uncertainty, considering the volatility that may exist in them. As a result of evaluation of the proposed methodology, the elements that make up the guide are the following. The project context. In this section, we will describe the objective and the project technical characteristics, and we will select the social, environmental, and economic alternatives that will compare with the base case. These three concepts are integrated to determine if the environmental impact after implementing each project is more sustainable versus the no implementation. And we will consider a temporal horizon of 20 years. In the analysis section, we will consider two different approaches, as we talked before. The first one is real option analysis. Once the probability that the initial net present value of the project will rise or fall is calculated using the binomial up-down model, the formula corresponding to each scenario is applied to each probability of the year end, and then all periods are discounted, eliminating the effects of the up and down probability, and is brought to present value, removing the effect of the interest rate. From the amount obtained, the price of the initial investment is subtracted, and the present value of the project is taken with real options. The evaluation with real options can give clearly for optimal decision making when faced with the need or desire to modify the original characteristic of the project. Definition of outcome measures. For the purpose of this guide, we will quantify the GHG emissions when comparing the tons of these gases emitted in the initial scenario versus the energy efficiency measure scenario. The amount of emission generated should be notably less, so that the project is justified in environment terms. This measure can represent the added value in projects that have minimum profitability levels, since international cooperation agencies have as their main goal the reduction of GHG emissions above financial profitability. Cost estimation to determine the cost incurred with the reference measure, that is, emitting or avoiding GHG emissions. It is necessary to relate the cost of producing the megawatt per hour from which the GHG are emitted. Any environmental benefit translates into economy benefits for the SME and increases in the value of the implemented project. The second approach is cost-effectiveness analysis. And here we have the presentation of results. Once the results measures and the costs incurred to achieve environmental benefits in the project have been determined, it is necessary to evaluate whether these actions are cost-effective, not only with the initial scenario, but also with other options available in the market to ensure that the choice made is the best for the company. To determine which option is the most cost-effective, we must determine the cost associated with the implemented initiative, but also with the elements related to the measurement of the results, which is the emission of GHG, its savings, and the cost of producing them. Initially, there must be more than one alternative of efficient equipment to install and cover the needs of the company, of course. Then, besides to the cost of the equipment, its electrical consumption and the GHG emissions of each must be compared with to determine which of the option is the most cost-effective. There is equipment that, by its nature, may apparently be more convenient for the company compared to its competition, but in reality it is not, since it may be cheaper but is not as efficient, may be very expensive to install, or its very high loss of efficiency over time. Now I will present two examples with each technology. The intention of proposing two types of projects is to exemplify that the guide can be used both in large projects that involve implementation of renewable energies and in simple cases that only need energy efficiency measures. If anyone wants to review the calculations, please feel free to consult the complete document. The first example was the installation of a 350 kilowatts of power solar photovoltaic system that will allow the supply of clean electricity to 20 companies in a small industrial complex. The project needs funding for the project, so the source of funding are 70% from the bank, and the rest is the 30% from the SMEs. With this information, cannot be determined whether the natural volatility that exists in this project is associated risk could impact their performance. Applying this methodology, the variables that make up the real options model are calculated, and three possible scenarios are proposed. First one, increase the investment amount, reduce the investment amount, or shut down the project. As a result of the analysis, it is concluded that in the year 10, the most convenient is to expand it, since not only has a bigger net present value, but also the value of the option is positive, indicating that it should be exercised. The second model presents a case where SME wants to replace two air conditioning units of 3 tons of refrigeration each to reduce electricity cost, consumption, and GHG emissions that they generate. Both pieces of equipment are considered as a replacement option, are efficient, and meet the needs of the company. Equipment A is cheaper than equipment B, and it generates less GHG emissions. What makes it more cost-effective is that the cost of avoided emission is lower, so the company will choose equipment A over equipment B. There is equipment that, by its nature, that may apparently be more convenient for the company compared with, to its competition, But since there are efficiency issues with use and high installation cost, for this, it is recommended to carry out a cost-effectiveness analysis using as a reference the GHG emissions that will also serve to provide a comparative differentiation element to the available choices. So, as conclusion, we have that real option cost-effectiveness analyses are an extremely valuable analytical tools for decision makers that help mitigate uncertainty while adding versatility for strategic changes that can maximize both profitability and positive environmental impacts. By integrating real options in the analysis methodology allows close monitoring of projects whose characteristics can be modified throughout their life and in case of existing financial obligation during the tenure of the loans. This tool is particularly useful to maximize profits and minimize losses and risk associated with the project, without having to leave aside the non-quantitative elements of the project. Additionally, the cost-effectiveness evaluation allows the incorporation of qualitative variables, whose results allows the decision maker to carry out a comprehensive review of the impacts of the projects to determine whether, in addition to being financially profitable, it is environmentally viable and positive for the society. Finally, banks have the enormous challenge of expanding their traditional credit metrics to begin evaluating the integral impacts of the project beyond economic profitability, so that, added with the participation of cooperation agencies, access to preferential financing with lower cost and longer term can be achieved, so that the number of benefited SMEs increases and consequently sustainable development is established in the production process. In economies where there are international support mechanisms to promote climate change mitigation actions, this guide can be replicated since it allows to identify, in addition to the profitability component, the environmental and consequently social impacts that the project generates. Thank you all for your attention. I hope these have been of interest to you. Thank you.
Hello, everybody, and thank you for joining me today. My name is Luis Mejia, and I will be presenting my research project that we named as Multi-Product Stochastic Programming Model for Supplier Selection in a Humanitarian Relief Chain. I'm currently working with Dr. Jania Astrid Saucedo Martinez. This is the agenda that we'll be addressing today. I would like to start with a brief definition of a disaster. It is an event that has great negative impact in society and its environment. It could be natural-made, such as hurricanes, earthquakes and volcanic eruptions, or man-made, like air crashes, nuclear accidents, or wars. Humanitarian logistics is defined as the process of planning, implementing, and controlling the cost-efficient and effective flow and storing of goods and materials, and the related information, from the point of origin to the point of consumption, to ease the suffering of vulnerable people. Mexico is a disaster-prone country given her geographical position. For the most part, the country is struck by hurricanes and earthquakes. Between 2000 and 2015, a total of 2,419 hydrometeorological events happened in our country. In the same period, 51,998 earthquakes occurred in Mexico, but only 6 were registered with a magnitude higher than 7 in the Richter scale. What are the consequences of these disasters? They leave behind hundreds or thousands of casualties. We have interruption in services like water and electricity, scarcity and oversupply of products, and we have many actors involved in the supply chain. Van Wassenhoff identifies 4 stages in the humanitarian logistics. 2 of these happened before the disaster. We start with the mitigation state, where the community runs risk assessments on infrastructure to get ready for a disaster. The preparedness stage, where we start acquiring machinery, we start educating people, and we get ready for whenever a disaster occurs. And 2 stages after the disaster, which immediately begins with a response stage to rescue people and transport goods to bring to the disaster zone. And the rehabilitation stage, where we try to get the community back to their normal lives. We have found that many of the humanitarian organizations, whenever a disaster occurs, they start procuring their items. This, however, causes high purchasing cost. We have a scarcity of products that we need, and we have long lead times. Some authors have proposed to have prepositioned inventory. This is to have relief items in a warehouse. However, this carries high storing cost, complex administrations, and risk of obsolescence for some items. The objective of this research is to minimize the cost associated with the procurement of humanitarian relief items originated by a sudden demand, and analyze the supplier selection tools for decision-making in a humanitarian supply chain. Our hypothesis is that the procurement of humanitarian relief items could be improved in cost and delivery lead times through the implementation of quantitative tools that help integrate the humanitarian supply chain. We have found some differences between humanitarian and commercial chains. The main objective of a commercial chain is to maximize the profit, whereas in the humanitarian logistics is to save lives and ease the suffering. We have a generally stable demand in commercial chains and a very irregular demand in humanitarian chains. We can go through all of these human resources. In commercial chains, we can do professional careers. We have commercial products. The stakeholders are usually customers and shareholders. The inventory control has safety stock in place, and the performance is very well known for all the logistics field. In humanitarian chains, we have a high rotation of volunteers. We move along the chain people, food, and shelter. The stakeholders are usually donors, governments, and NGOs. The inventory is difficult to control, and well, for performance, we only have the response time and the percentage of demand covered. In 2001, the International Federation of Red Cross and Red Crescent Society adopted framework agreements as part of their strategy to procure humanitarian items. The supplier reserves an agreed capacity for the buyer, who commits to purchase the number of items established in a given period of time. We have found some supplier selection tools in this process. We have the pre-qualification methods that are not limited to categorical methods, fuzzy set theory, data envelopment analysis, case-based reasoning, and analytical hierarchy process. And final decision models, which we usually find nonlinear and linear programming models, mixed integer programming, statistical models, and artificial intelligence. We have done some literature review using terms such as humanitarian logistics and supplier selection, and we have found several papers that use stochastic programming model and some other papers that use multi-criteria tools like AHP and fuzzy TUPSes. However, it's important to see that not many of these authors have used a budget in this field, which is very important given the fact that humanitarian organizations usually don't carry large funds to do all these activities in the response stage. The methodology of this research, we're going to use the one that we found in Winston. We start with a problem formulation, we collect the data, formulate the model, we verify that the model is appropriate for this problem, and then we select it. For our case study, we'll be addressing a humanitarian organization, which is really a statutory agency, Protección Civil Nuevo León. We're going to call it PCNL. PCNL has multiple suppliers. For 2020, they hold a budget of 21 million pesos. And if their capacities are exceeded during a disaster, they are able to request help from the federal government. The regional context of this case study is the state of Nuevo León. This state has frequent storms and hurricanes. It holds a population of 5.13 million inhabitants, and 80% of the population inhabit the metropolitan area. Items needed during the response stage could be bottled water, energizing drinks, PICs, access, gloves, etc. For our formulation of the model, we have the objective function, which is going to be a two-stage stochastic programming model. The first stage, we're going to select the candidate suppliers, and in the second stage, the model will optimize costs. For constraints, we have the quantity of suppliers to be selected, the demand that has at least to be fulfilled 10% for each item, and 30% in the first lead time interval, say 5 to 7 days, for example. We have a budget, a reserve capacity, and lead time and quantity intervals. It's a very common practice that some suppliers can offer discounts according to the quantity that you are buying. For example, they give you a price of 10 pesos, but in the first interval, if you buy between 0 and 499, and they give you a small discount if you buy over 500 pieces. This is a mathematical model that we have formulated. And for this, we have to start formulating the scenarios. We consider 5 regions. This in this picture is the state of Nuevo León. We consider the north, east, citrus, south, and metro regions. 3 types of phenomena: tropical storms, hurricanes categories 1 and categories 2. The east and the citrus regions are considered to always be struck by these hurricanes, given the fact that hurricanes usually approach the country from the east side, from the Gulf of Mexico. So it is very, very common to see these regions struck by this type of phenomena. With this, we have 6 combinations and 3 types of impact, so we formulate a tree of scenarios. We have tropical storms, hurricanes category 2, and hurricane category 3, with 6 combinations, each giving us a total of 18 scenarios. For the probability of occurrence, we have generated a random number, and then we use a scale probability. So the sum of all these probabilities will give you 1. The tree of demand scenarios, we also generate a random number between 100 and 5,000. These are the casualties or people that will be generating demand in case of a tropical storm, between 5,000 and 15,000 for hurricanes category 2, and 15,000 and 50,000 for hurricanes category 3. Given the fact, like we said before, that 80% of the population inhabits the metro region, we have this little formula that will give us a total of the people that will demand any product for each region. For the experimentation, we have created an instance for items of bottled water and blankets. We have set minimums and a reserve capacity for each of these items. We have calculated that for each person, we will use 2 liters of water for 7 days per person, and 30% of casualties will usually attend a community shelter. So out of the total demand, we only are going to consider 30% to be blanket demand. The budget what we have here is 1.5 million pesos. We have 5 candidates per item. The agreement of settling the agreement cost for settling a contract with them is 1,000 pesos, and they will give us a 5% discount for purchases over 500 blankets or 1,000 packs of bottled water, and 5% discount if the delivery is within 7 to 10 days. For this experimentation, we have used GAMS as a software and used the solver Cplex. The solution to this case study gives us the following results. The model has selected 3 sup-pliers out of 10. The budget is used at 100%. The demand is satisfied at 100% in 14 scenarios and up until 58% in the rest of the scenarios. And more than 50% of demand could be supplied within the first lead time interval, which could be between 3 to 5 days. We have analyzed the budget to see how it behaves. If we set the same instance with less than 1.5 million pesos as a budget, the model will be infeasible. So we will need to request aid from the federal government. The solution for our case study was the budget was set at 1.5 million, selected 3 suppliers, and we still need to request products from the federal government. So we were increasing the budget, so the model was selecting more suppliers because we had the budget to purchase from the suppliers. However, when we reached 4.75 million pesos, The model selects 7 suppliers and it does not request help from the federal government. We also ran the model to consider each of the scenarios a deterministic model. Here we can see the suppliers that the model selects for bottled water and blankets. We have the procurement costs and the fixed costs and the total procurement costs. It is important to see here that for each of these scenarios, the budget is sufficient in case that scenarios 1 to 6 happened. This is the tropical storm scenarios. For the scenarios of a hurricane category 2, we can still, with the same budget, can cover all the demand. However, for the higher impact hurricane, which is category 3, in scenarios 15, 16, 17, and 18, we are not able to satisfy full demand with our budget, so we will have to request help from the federal government. As conclusions, by using the mathematical programming, the procurement cost could be optimized. The mathematical programming provides an optimal solution for supplier selection. 3 out of 10 suppliers were selected honoring the requirements and constraints of the agency. The service level requirements could be set for on-time delivery and meet the immediate needs of victims of a disaster. The model may assist a humanitarian organization in the decision-making process by defining a budget for certain relief items. The proposed solution is not limited to hydrometeorological disasters nor to the quantity of the items. Thus, it is applicable to other phenomena and relief items. In the worst scenario, the solution is able to offer up to 58% coverage by the suppliers given the limited budget of the instance. The contributions that we present to the logistic field is that an optimization tool is proposed for decision-making process within a humanitarian organization for supplier selection, that it is possible to reduce cost and delivery lead time and improve the service level of a humanitarian chain. This is, the agency will be able to fulfill the needs of a vulnerable population within less time than post-disaster procurement. It is possible to better integrate the humanitarian supply chain through the implementation of framework agreements to strengthen the relationships with suppliers. And humanitarian organization with an established budget is able to optimize the procurement cost of relief items given the approved supplier base. So, wrapping this up, this statutory agency can use this model to make decision as to how much money they can allocate to the procurement of certain relief items. Like we see in the budget analysis, they have to set a minimum budget for these 2 items, and they can set a higher budget if they don't want to request help from the federal government, so they can save time given the fact that transporting goods from the Federation to the disaster zone may be a longer process. And while in humanitarian organizations and humanitarian logistics, what we care about is easing the suffering of the people in the less time possible. This is part of the bibliography that we use for this presentation. I thank you all very much for your attention, and feel free to send me an email with any more questions.
Image classification applied to detection of letter defects for smart manufacturing. Authors Alberto Ochoa Cesati, Oliverio Cruz Mejia, Jose Mejia, Hazael Cerón Monroy. In the shoe production workshops, animal leather is used as a main raw material. Generally, an operator manually checks the surface of the leather, making sure that it doesn't represent defects that compromise the quality of the final product. This type of inspection is subject to human error, and uncontrollable factors can happen, which represents an opportunity for the automation of the processing through a system of artificial vision. The dataset was developed consisting of images of animal leather in good condition and with defects. The digitalized sample were subject to image processing using OpenCV and scikit-learn, and then using a convolutional network interfacing using TensorFlow kernels library in Python. Finally, the trainer model is capable of classifying new images into two possible groups: defective letter and defective-free letter. The trained model offers a 80% predictive accuracy and 85% reliability. Introduction. The Mexican footwear production industry has faced different challenges in recent years, derived from the competitiveness that has resulted from the opening of borders and the introduction of manufactured products in countries with the necessary resources to produce greater volumes with reduced production costs. Therefore, the need to develop and implement technologies focused on optimization and automation of processes arises, which possess a better competitive scenarios for Mexican companies. The relevance of this industry in Mexico is undeniable, since it represents 1.7% of the total manufacturing industry, contributed to 2.4% of the total employment of this area. Objective: to train a convolutional neural network, which is capable of classifying an image of letter surface into possible categories, with defects or without defects. Background: image classification based on neural networks has proven to be a powerful tool in the area of quality control, allowing an artificial vision system to be able to distinguish the defective pieces, automating the inspection process with positive results in the area of footwear, especially in the animal leather. Bong et al. 2018 and Leon 2019. For an image classification system, it is convenient to train a convolutional neural network. These are a type of neural networks that works with two-dimensional matrices, so it's frequently applied in the area of artificial vision, as in Simard et al. 2013. Next figure illustrates the operation of such a network. Here's the illustrated convolutional network, an example of image vehicle image classification, and we have an input figure, a picture, an image, the convolution or ReLU. Then we have the pooling process, the convolution plus the ReLU, and the pooling. All this section is called in the future learning section of the process. The complement is the classification. In the classification, the flatten is the first process, fully connected is the next process, and softmax is the final process. And here is an example of how the image classification is done. Background, more about the background. The construction of the network was done using a Keras library, which belongs to TensorFlow. The library facilitates the use of process of training deep learning models, as it contains a variety of previously validated deep learning frameworks, as in NADI and BASIS 2017. One of the advantages of this library is its ability to build robust models from relatively small datasets, less than 1,000 samples per class. Some useful features of Keras are the following. First is the fit generation, and the second is the image generation. And this is how our data argumentation strategy looks. We can see the two cats, and we can see how it can be modified, the image, through this process. Imaging processing consists of 3 stages: smooth, edge detection, and enhancement. Smooth. At this stage, the medium blur filter of the OpenCV library is used. This filter is classified as a smooth filter, and its purpose is to reduce the noise in the images, which is used to facilitate the conversion and degree of detection, according to Perrenault and Heber 2007. Next step is edge detection. The combination of the Sobel and Laplace operators, both of which are designed for edge detection, has been used before and has proven to be efficient and compatible with each other, according to Gupta and Powell 2016, allowing sharp changes in the original images to be successfully highlighted. Third section, enhancement. The last stage of this digital imaging processing is an image enhancement using the Pillow library, available in Python. The contour filter is used, which gives us a negative of the input image and provides the contour of the input image. This image processing is sufficient to be used in the training of the neural network, since the result is a binary image that highlights only the relevant contours edges of the piece and defects with it. Let's talk about the dataset. In order to obtain a sample of significant size for later analysis, we use a hardware production workshop located in the city of León, Guanajuato. There was conducted the experiment of this part. The workshop was asked to a wide variety of letter samples composed of elements in good condition and elements with defects. The total sample consists of 92 defect sheets of letter, among which defects are predominant, which will be described below. Here you have the defects. The letter has the characteristic of not containing wrinkles, folds, scars, or holes in the surface. The absence of these defects allows its proper handling in the production process of the hardware. And here we have two types of defects: scars on the left side. Here we can see in the middle in the scar, and grazes in the right side. So these are two defects that should be detected by our trained system. Neural network training. To develop the image classification system, A convolutional network was trained using TensorFlow kernels library. The network was configured so that the training consists of 20 epochs with a learning rate of 0.0004 and a minimum accuracy of 75%. Raising any of these parameters, reducing the case of learning rate, offers a better quality training, a more precise learning process, although this requires a computer with better performance than the available and long waiting times, so it was decided to keep this configuration of the system. So the neural network training can be improved, however, more computational power is needed for this. Here we have some of the results. The kernel library provides us with the information on the result of the training, which was 80% accurate. To measure the validity and check the reliability of the model build, the data set called test set use, which consists of 20 images, 10 of them of letter in good condition, and 10 of them letter with defects, in order to check if the model is able to classify them. In the right side, we have the table, and we have images description with flawless letter, and the total. So the test sample was 10 for flawless letter. Hyperflow letter was 10 as well. So the total was 20 pieces. The correct prediction, our results, out of these 10, 7 were predictions correct according to the flaws or no flaw. And in the case of the flaw letter, 10 out of 10 were detected. So the total was 17 out of 20. This is how efficient was the process for our process. Result: the model works well in detecting errors, as it successfully sorts out images showing defective letter parts. However, only 7 out of 10 images made accurate prediction. This means that the system will be potentially reject 30% of the samples that are in good condition. It would be able to identify an error of 100% over time. Overall, the system needs to make prediction with an 80% effectiveness. So up to here, we have explained the reasons we have in Mexico and strong industry for shoe production. We have shown how the learning of the neural network was taken and the process itself. So according to our results, the learning of the network is not too bad. We can go back at results. In the case of flawless letter, well, we have a percentage of correct predictions of 70%. However, in the case of flawless letter, it is much better the performance of this. So one is 70% and the other is 100%. So in average, 80% is the effectiveness for this. So we consider that the system can learn the neural network can learn well in terms of practical terms, the process, and it can work well in industrial setting, and it can be an effective implementation. This is all. Thank you for your time and presentation.
me to present you our investigation entitled Suppliers Analysis and Selection to Improve Supply Chain Performance in this for EAI COMPSE 2020. The authors of this article are Engineer Inaivis Lázaro Ibáñez Delgado, Dr. Tomás Eloy Salas Fiero, and Dr. Hania Astrid Saucedo Martinez. The content of this research includes introduction, background, methodology, results, and finally, conclusion. As an introduction, we can begin to say that nowadays, international successful companies are supplying the world's best competitive advantage, making it vitally important for them to develop competitive strategies based on value aggregation and simultaneous cost reduction. For that reason, suppliers and customers must be partners in the supply chains and not be faced with isolated authorities. Having good suppliers can't only mean having quality raw materials, but also quality products, low cost, security of always having the same product whenever they are required, basic engineering, collaboration in design and innovation, construction and operations engineering, among others. According to the analyzed literature, within the common problems as a result of the poor supplier selection, approximately 45% are associated with provisioning problems. The deficiency in the provisioning process is an factor that negatively affects the production process, increasing its variability and the risk of obtaining a product out of specification. On the other hand, an inadequate supplier selection has a negative impact of the supply chain, also bringing with it an increase in cost, late deliveries of products, incomplete deliveries, and lengthening of cycles. For that, the objective of this article is to propose a methodology for the supplier's analysis and selection to improve the performance of the supply chain. For decades, researchers and professionals from various branches have paid close attention to the supplier selection and the methods to be able to select them properly. Supplier selection is the multi-criteria problem, and it's not easy to make the decision about which is the best supplier, and therefore methodologies have been developed to help in this process. For example, Annealing in 2011 provides a 5-step supplier selection process. The first step is to recognize the needs to supplier selection. The second is to determine the selection criteria. As a third step is to limit suppliers in selection group. The fourth is to determine the supplier evaluation and selection method. And finally, we ask to select suppliers and react agreement. There are multiple criteria to be able to select the right suppliers. Each of these aspects must be selected according to the needs of the business. They are inherent to each product supplied, and they are the great importance within the selection model. In literature and the practice, the most used criteria for supplier selection are quality, sales price, and delivery times. However, there are many other criteria. For example, administration capacity, logistics performance, among others. Another fundamental aspect of the supplier selection process is to choose the method or technique. The selected method must be consistent with the analysis of the context, the realities of the supply chain, and selected criteria. Some of these techniques used for the supplier selections are analytic hierarchy process, linear programming, goal programming, simulation, cluster analysis, artificial neural networks, physics set theory, spec system, and also we can find integrated methods by 2 or more techniques. This article proposes a first-step supplier selection methodology. The first step is to determine the general objectives of the company with respect to the provisioning process. Second step is determination of the attributes to be evaluated. Third step is evaluation of suppliers using an integrated methods in order to finally select the supplier. As the first step, a follow-up should be carried out on all of the suppliers that have influence in the market, as well as the main problem that the company presents to lead to the need to select a new supplier. With respect to determination of the attributes to be evaluated, These criteria or attributes must be chosen by the decision group or the company's election group from direct observation to the process or consultation of criteria that are used in leadership. Each company is a special case that presents its own needs, and the criteria must be selected according to these problems. Once the selection criteria has been defined, the next step is to select supplier using a specific method. The selection method should be consistent with the analysis of the context, the reality of the supply chain, and the selected criteria. With respect to the final selection, it is recommended that the supplier that has been chosen is aligned with the objectives and strategies plans of the company. The application of the proposed methodology will be carried out in the resin purchasing process as one of the main raw materials used in the production of plastic products in a company that supplies these products to industry in general, including automotive industry. The problem in this case study lies in the need to select the appropriate suppliers that can improve the performance of the procurement process of that company. To determine the critical indicators for the problems that concern us, and as part of the second step of the methodology, the Delphi method was applied. This tool aims to obtain the most reliable consensus of opinions from a group of experts regarding a specific topic. For the application of this method, the main opinions of the leadership regarding to the main attributes, tutorials, or indicators for the selection of suppliers in the automotive sector are taken. The stage for the application are following. First, determine the main objective of the investigation. 2. Design of the questionnaire by the coordinating group. 3rd, selection of the expert group. 4. Obtain the response of the expert group. And finally, interpretation of responses and evaluation of actions. From the research carried out, 45 criteria were obtained. The result of the application of the method are shown in the table, where E1, 2, 3, 4, 5, 6, 7, 8, 9, 10 represent the experts. After analyzing the results of the application of the Delphi method and using the Pareto principle, it can say that of the 45 criteria or indicators mentioned by the experts, the most important or critical criteria that represent approximately 20% of the total score are the following: adequate quality of the suppliers, certified quality management system, adequate sales price, minimum delivery times, and technological capacity. Now, the next step is to evaluate if these criteria can be used to select the suppliers. For that will be used Kandler's coefficient of concordance. This coefficient measures the degree of the agreement between a group of elements and a group of characteristics. It is commonly used in attribute agreement analysis. Kandler coefficient values can range from 0 to 1. This statistician follows a chi-square distribution. For the development of this test, two hypotheses are used. Null hypothesis will be when there is no agreement among the experts, and alternative hypothesis will be when there is agreement among the experts. Table shows the value of the coefficient W with 0.05 as level of significance. W is equal 0.31194, and this value is greater than 0. And P is equal 0.0141, then less than 0.05. For that reason, alternative hypothesis is accepted. Therefore, we can conclude that there is agreement between the experts. For that reason, we will use the criteria: quality of the suppliers, quality management system, required sales price, minimum delivery times, and technological capacity for the next steps of the proposed methodology. Once the criteria are obtained, suppliers must then be evaluated according to those criteria. For this, will be used an integrated method by ASP and neural networks. Firstly, for the supplier's evaluation, the ASP method will be developed. AHP helps to make decisions in a more rational and understandable. It generates numerical priorities from criteria and organizes them into the priority comparison matrices. Its main advantage lies in the possibility of structuring and hierarchizing a multi-criteria problem. This figure shows the AHP methodology to be followed in this research. As a first step in the application of AHP method, the prior comparison model should be made among the select criteria. For this, experts assign weight for each criteria respect the others using static scale from 1 to 9. This scale shows in the table. The prior comparison matrix between the selection criteria is shown in the table, where we have the average vector as a result. It is essential in this step to determine the term called consistency ratio. This value for the number of characteristics in this case must be less than or equal to 0.1. After calculating this value, we can say that the value is 0.08952. As consistency ratio is less than 0.1, it can be said that there is an acceptable consistency among the space judgments. Therefore, we can use these criteria to evaluate each of the sup-pliers. Subsequently, the 5 alternatives are compared with respect to each of 5 criteria, resulting in this matrix representing the table that is composed of the average vectors of each comparison. As our objective is to decide based on the 5 criteria and their importance, we proceed to multiply the matrices. One of them is composed for each of weight of the alternatives based on each of the criteria, and the others is weighting of the criteria. The final average vector indicates the weight of each alternative and therefore allows us to choose the best option. Based on the 5 criteria and their importance, the best alternative is sup-plier 1, because it has the highest weight, 31%, followed by sup-plier 5, sup-plier 3, sup-plier 2, and finally sup-plier 4. To give our decision more reliability and robustness, we applied the artificial neural networks. Artificial neural networks is a model inspired by the functioning of the human brain. It is made up of the set of artificial neurons that are connected and transmit signals of each other. It's usually used to solve complex problems. It can create patterns and also recognize information. In our case, we used it to give more reliability to our decision. The methodology to be followed for the development of the neural networks in our case study is represented in the figure. There are 4 aspects that characterize a neural network: its topology, type of association between the input and output information, the layering mechanism, and the form of representation of this information. This slide shows all of the information that will be used to train the network. For this training, we used MATLAB R 2015 software. In the first image, we can see the neural network topology. On the other hand, it's too important to determine if the network is correctly trained or not. The second image represents regression value. This value of training, test, validation, and general must be very close to 1. The closer to 1 that value is because the network is better trained, or in the other terms, is good fit. In this case, the resulting value of R is 0.99463. So that means that the network is good fit. After confirming that the network is currently trained, we proceed to simulation of the network. Network is simulated with data were entered representing the evaluation of the 5 sup-pliers for each of the 5 criteria. That output of the network corresponds to the weighting of each of the 5 suppliers. So the network output, it shows the supplier with the highest score is supplier 1. So it is a selected supplier. It's important to know that the output of the networks correspond to the results derived from the application of the AHP. In order to definitively select supplier 1, it has been informed for the company's medium and long-term objectives in order to obtain an alignment of objectives between both. This will enable evolutive change and improvement in the performance of the supply chain. In this case, supplier 1 complies in these aspects. So it was finally the supplier selected to supply the resin within the agreed period. As a conclusion, we can see that this study represents a procedure to analyze and select suppliers from exhaustive search and the analysis of academic literature related to methodology or process to properly select suppliers, selection criteria, and even some of quantity methods have been used. The proposed methodology was applied in a case study with the objective of selecting an appropriate supplier to supply resin for the company within the automobile sector. As important data, an integrated AHP and additive network method was applied as a quantitative method to select the supplier. Concluded that if the supplier can be obtained objectively according to the needs of the company using the same methods. There are some of the bibliographic references that I used to this research. Thank you for watching.
Good day, everyone. My name is Marcelo Galas, and I am currently finishing my master's degree in Technologies for Sustainable Development at the Anáhuac University in Mexico. Today, we'll be looking into the feasibility analysis of a supply chain for castor oil biodiesel distribution in central Mexico based on a B20 mix. The aim of this paper is to analyze the feasibility of establishing a supply chain for castor oil biodiesel distribution in central Mexico, based on the distribution of land with the highest castor oil seed yield potential. We'll start by looking at the government stance on sustainability and clean energies. Then we'll look at the current demand and supply of diesel in Mexico and central Mexico. Mexico's current government campaigned with an agenda highly focused on sustainability and clean energies. However, the actual policies are oriented towards the exploration and exploitation of oil fields, together with investments in Pemex, Mexico's state-owned oil company. The goal of these policies is to reduce Mexico's reliance on oil product imports, like gasoline and diesel. Mexico's main fossil fuel demand comes from gasoline. However, diesel has a sizable demand too. In 2019, Mexico had a national average daily demand of 392,000 barrels of diesel, of which 130,000 barrels were produced locally. This represents around 33% of the demand, leaving 262,000 barrels to be imported daily, almost 67% of the remaining demand. The region of central Mexico is composed by 7 states: the state of Mexico, Querétaro, Hidalgo, Puebla, Tlaxcala, Morelos, and finally Mexico City. The daily demand of diesel for this region is 78,000 barrels, which accounts for almost 22% of the national daily demand. Of these 78,000 barrels, 20,000 are produced in Mexico, while around 74%, 58,000 barrels, is imported daily. Considering that the government is looking to reduce the reliance of Mexico on oil product imports, the production of biodiesel can be a sustainable aid to meet the diesel demand, with the added benefit of supporting the development of the agricultural sector. The mass production of biodiesel based on commercially cultivated edible plants is not considered economically feasible given the shortage of food it would trigger with a subsequent rise of food prices. Taking this into account, other plants that meet the requirements must be considered as sources as long as they do not endanger current food production capabilities. One such plant is the castor oil plant, which has a relatively high yield of biodiesel and whose byproducts have a variety of uses. Mexico has around 10 million hectares of land that meet the requirements for the cultivation of the castor oil seed. Resinomex is one of 3 biodiesel refineries in the country, which has a capacity of refining approximately 3 million liters of biodiesel per month. The other refinery considered for this study is DERT, located in the state of Mexico, which has a capacity of refining around 2 million liters of biodiesel each month. The third refinery, Enrimex, is located in Baja California, in the northwest. It was not considered as a viable location given the distance from central Mexico. Finally, we are considering a B20 biodiesel mix, which means that each liter of diesel contains 20% of biodiesel. This mix is the maximum recommended for use on unmodified engines, as well as ensuring a balance between fuel consumption and energy output. We'll now look into the supply chain design and analysis, starting with the production capacity and requirements, following with the demand and biodiesel distribution, and wrapping up with the resulting supply chain model and its simulation. Mexico's 10 million hectares of land that meet the requirements for castor cultivation have different yields depending on each region. In order to estimate the production capacity, we'll consider an average of 850 kilograms of castor oil seed per hectare. Another consideration we'll be taking into account is that each kilogram of castor oil seed yields an average of 0.65 liters of biodiesel. From these considerations, we can calculate that each hectare of castor will yield around 1.46 barrels of biodiesel. Applying this yield to the 10 million hectares of land, we have that they can yield around 14.6 million barrels per harvest. Considering that each harvest takes around 180 days, this means we have 2 harvests per year, and the total production capacity of biodiesel is approximately 29.2 million barrels of biodiesel per year. Central Mexico current annual diesel demand is approximately 31.27 million barrels. However, we must take into consideration that using Castor biodiesel increases fuel consumption by 3%, which means that if we are looking to substitute 20% of diesel supply with biodiesel, we must adjust the annual diesel demand to 32.25 million barrels. This means that in order to meet the demand of biodiesel, we must produce 6.45 million barrels per year. This amount of biodiesel requires 4.4 million annual hectares of Castor, which represents around 17.6% of the total hectare national capacity. For our supply chain, we'll consider 3 Castor cultivation regions: Cerritos in San Luis Potosí, Tierra Blanca in Veracruz, and Yogana in Oaxaca. Of these 3 regions, the only established one is Yogana, which provides the Castor process by Rizinomex. To calculate the approximate production capacity of the other 2 regions, given that we did not have access to the regional data from which the map was drawn, a histogram analysis of the map was made. The yields used for the analysis were 850 kilograms per hectare for light green and yellow areas, and 1.35 tons per hectare for the dark green areas. The base image for Cerritos is the one on the far left. This image has a width of 197 pixels by a height of 157 pixels. Using the map scale located at the bottom of the image, we get a width of around 657 kilometers and a height of 523 kilometers, for a total of 343.6 thousand square kilometers, or 34.4 million hectares. After using image processing software to filter out different shades represented by the second and third image, we were able to calculate that the high yield area of this region accounts for 13.72% of the image, or 4.7 million hectares, while the medium yield area is around 5.48% of the image, or 1.9 million hectares. This region accounts for 66% of the total national area, which can provide around 11 million tons of Castor per harvest. For Tierra Blanca, the base image is the one on the near left. This image has a width of 78 pixels by a height of 62 pixels. Using Mexico's border with Belize as the scale, we get a width of around 491 kilometers and a height of 390 kilometers, for a total of 191,000 square kilometers, or 19.1 million hectares. Just as we did before, after using image processing software to filter out different shades, we were able to calculate that the high yield area of this region accounts for 1.2% of the image, or 229,000 hectares, while the medium yield area is 5.96% of the image, or 1.1 million hectares. This region accounts for 13.69% of the national area, which can provide around 1.28 tons of Castor per harvest. In the case of the Yogana region, we know it provides Castor to produce 3 million liters of biodiesel per month. This means that the region provides enough Castor to produce 18 million liters of biodiesel per harvest. Considering this, we can calculate that the region has around 77,000 hectares per harvest, using an 850 kilogram per hectare yield. Adding up the hectares from the 3 regions, we have a total of 8 million hectares, or 16 million hectares a year, considering to harvest per year. This is more than enough land to meet the required 4.4 million hectares to produce the 6.45 million barrels of biodiesel per year. For our demand distribution, according to a listing of service stations from 2017, there are 2,964 service stations in central Mexico, distributed among the 7 states of the region. Given the limitations of the educational license of any logistics that was used, we were restricted to a maximum of 100 client nodes in our supply chain model. This led us to make a random selection based on the amount of service stations each state has. The amount of diesel required by each state was then divided among the selected service stations in order to calculate the demand distribution. As we saw earlier, the biodiesel refineries that we'll consider for our model are Dirtec in the state of Mexico with a production capacity of 2 million liters per month, and Risinomex in Oaxaca with a production capacity of 3 million liters per month. As these two refineries are unable to supply enough biodiesel to meet the demand, we'll be using an additional virtual refinery in Poza Rica, Veracruz, that will show us how many additional refineries would be needed to meet the demand in the region. For our biodiesel distribution parameters, and given the limitation of the license used, we selected 7 storage and distribution centers, TARs for their initials in Spanish, that are part of the national petroleum infrastructure and that are located within the region, as well as choosing to ship the biodiesel and Castor using 31-ton tank trucks with a cost of 1.08 Mexican pesos per ton per kilometer. Another consideration was that the biodiesel reserves would be distributed among the TARs. Finally, the biodiesel mixing to reach our B20 goal would be done in the same TARs. This map shows the components of our model. In green, we have our Castor cultivation zones, yellow for our biodiesel refineries, red for the storage and distribution centers, and the selected service stations are shown in blue. Our supply model uses network optimization. In order to consider our supply chain model feasible, the supply chain must meet the biodiesel demand while providing the lowest transportation cost possible using the selected distribution method. After simulating our supply chain model using any logistics, we obtained the following results. Only 2 Castor cultivation zones will be required, Cerritos in San Luis Potosí and Yogana in Oaxaca, while Poza Rica will remain unused. The 3 refineries will be used with 87% of production coming from our virtual refinery. This means that currently only 13% of the demand can be met with the existing refineries. Out of the 7 selected storage and distribution centers, only 6 will be used, and we'll have a total transportation cost of 4.4 million pesos. Our results showed that while it's technically feasible to establish a supply chain that can meet the demand for Castor biodiesel in central Mexico using a B20 mix with the available Castor cultivation zones, it would require building 12 additional refineries with a similar production capacity as Risinomex, given that the current refineries only meet 13% of the demand. A future study using a commercial license of any logistics could use the supply chain model presented here and expand upon it, considering the entire universe of service stations and TARs that exist in central Mexico, as well as production capacity of each Castor cultivation region, the storage capacities of each TAR, and as well as the evaluation of possible risks. Another source of biodiesel raw materials can be found in waste oils, although the main obstacle it faces is the logistics of collecting and transporting them to refineries. One final obstacle that is faced, not only by Castor biodiesel and waste oil biodiesel, but by all renewable energy sources, are the policies set by the current Mexican government. As a final thought, I'd like to leave you with the idea that humanity can achieve great things when we work together to solve those problems that influence all of us. I'd like to thank all of you for your time today and hope to continue working with all of you in making the world a better place.
Hi everybody, this is my presentation about the hub location problem for medical care during epidemic outbreak. This paper was developed by Marmolejo Saucedo, Jose Antonio, and Rojas Arce Jorge, and this is me. Okay. Introduction. This study presents a proposal for the hub location for medical care during epidemic outbreaks. A problem of coverage of medical services that offers a radius of medical attention to the population is analyzed. Two criteria are shown for the location of health services. Finally, based on public health policy recommendation, the solution is proposed for a hypothetical case. In the case of the health system, such as that of Mexico, that has structural problems and a 70% full supply of medicines, facing a public health challenge such as COVID-19 pandemic implies making value-added proposals that allow face contingencies like the current one. The design of a resilient medicine supply chain that can serve as a response to unexpected risk in the health system requires the participation of the different agents involved in the supply chain. In addition to the stewardship of the health department that allows the integration of wills and joint actions. In the framework of an epidemic, it is necessary to guarantee medical supplies, medicines, vaccines, supplies, in addition to basic products, food, water, etc. To guarantee the supply of these products, it is necessary to have strategic storage and distribution centers that communicate with the expected demand points in the event of a contingent. It is precisely the problem of designing an emergent logistic network in the face of disruptive events. For this, it is necessary to define the number and location of distribution and collection distribution algorithms that guarantee the best performance of the network, as well as the definition of the required optimal inventory levels, replacement policies, transportation and distribution according to the health contingency that is being faced. This is figure about the situation in this situation. Statement problem. The challenge is not less considering the complexity in the prediction of epidemic outbreaks. However, based on historical data, it has been possible to adequately model the probability of occurrence and possible scenarios of the magnitude of the problem. Stochastic variable and different simulation approaches must necessarily be included to obtain robust models. Currently, there is a specialized software that allows integration of different paradigms into hybrid models that allow generation technical evidence for public health decision making. Resilient supply chain model. We consider the model into a generalized network. The model is a mixed integer linear problem. Let K be the set of manufacturing plants and element K identifies a specific plant of the company. Let I be the set of potential cross-docking warehouse. An element I is a specific cross-docking warehouse. Finally, let J be the set of distribution center. A specific distribution center is any J, and let 0 the set of integers 0 and 1. Parameters. Capacity of plant K, capacity of cross-docking warehouse, fixed cost of opening cross-docking warehouse in location A, transportation cost per unit of the product from the plant K to the cross-docking warehouse. Cost of shipping the product from the cross-dock I to the distribution center. Demanded distribution center J. Decision variables. We have the following set of binary variables to make the decision about the opening of the cross-docking warehouse and the distribution for the cross-docking warehouse to the distribution center. Okay. Single cross, this is the formulas. I think that is not to explain. Let's look the screen. Single cross-docking warehouse distribution center, cross-docking warehouse capacity, the amount of items. The objective functions consider that in the first term the cost of shipping the product from the plant K to the cross-docking warehouse. The second term contains the fixed cost to open and operate the cross-docking warehouse. The last term incorporates the cost of fulfilling the demand of the distribution center. Constraint 2 implies that the output of plant K doesn't violate the capacity of plant K. Balance constraint 3 ensures that the amount of product that arrives to the distribution center J is the same as the product sent from the plant K. The demand of each distribution center J will be satisfied by a single cross-docking warehouse. This is achieved by constraint 4. Constraint 5 bounds the amount of products that can be sent to the distribution center J from an opened cross-docking warehouse. Constraint 6 guarantees that any open cross-docking warehouse I receives at least the minimum amount of demand requested by a given distribution center J. Constraint 7 ensures that the minimum demand of each distribution center J is considered. Finally, constraints 8, 9, and 10 are the non-negative and integration conditions. Case study. In this section, we describe the case study. In particular, we consider the pharmaceutical supply chain in Mexico. The supply chain is made up for 4 echelons: 2 factories, 1 central distribution center, 3 regional distribution centers, and 32 wholesale truck distributors. These facilities and clients are scattered throughout the country. Figures 1 and 2 represent the current structure of the supply chains. Okay, in the table 2, you can see scenarios addressed in the case study, and scenario 1, 2, and 3. The one is one factory is closed due to the halt contingency breakdown time, 45 days. When this is closed, 30 days. And 3, scenario 3, all facilities are closed, breakdown 50 days. Table 2 shows the distribution scenario considered. All network diagrams were implemented in CytoScript software. See lab. Solution methodology. The solution methodology used in this research is based on simulation optimization. The Annealing logistics software was used to develop the what-if methodology. This software used CPLEX as an optimization engine to find the best solution within a set of possible solutions. First, the current situation of the pharmaceutical company's supply chain is modeled. Subsequently, the elements of facilities that make up the supply network are optimized. Several operating policies of the chosen supply network are simulated. Finally, disruptive events are generated to test the resiliency of the proposal to the previously defined disruption scenarios. See Figure 3. As you can see this figure, the factories, see and really see the whole center is past integration, no? Because they use this software. Computational results. Considering the 3 different scenarios, it was found that scenarios 1 and 2 are those that cause the greatest negative impact on the operation of the supply chains. For this, and the reason of extension of the document, analysis of results shows the performance indicator for scenario 1 and scenario 2. After running the documentation and simulation routines, the result obtained are as follows. In the first instance, performance indications for the current structure of the company were analyzed without disruption. Afterward, the various scenarios were simulated. The variation experiment function incorporating LAX was used to compare various key performance indicators. Figure 5 shows the current supply chain network structure. As you can see, it's in this map of Mexico, what is the current supply chain network, because that is solved that problem present. Additional result, key performance indication proposal solution, and you can see available inventory, demand, and products backlog, demand replies, product per customer, demand received producers, fulfillment received products on time, fulfillment received products, fulfillment ships orders. The capacity, products produced, profit, and service level by products, total cost, transportation cost, travel distance. And you can see in this part the cost, yes, and profit, and total cost. You can see it's possible to obtain a gain, no? And the number of pieces. For scenario 1, the service level by product, the available inventory for all the facilities and the average delivery time are shown in figures 7, 8, and 9, respectively. Scenario 2, see figure 2 as mentioned above, was the one with the greatest disruptive effects, and this is the scenario that generates less profits. As seen in figure 10, the level of service deteriorated to levels of 60% and 40% for each product. Figures 11 and 12 shows the available inventory and lead time. Once scenario 2 has been optimized, see figure 4, the result of key performance indicators are reflected in table 3. In this scenario, the highest profits are generated with a service level about 95%. See figure 13. Available inventory and lead time are shown in figures 14 and 15. Finally, the proposed to optimize scenario 2 is shown in figure 6. You can see the other map with the scenario 2 is optimized. Conclusion. According to the scenarios outlined for the company, the epidemic outbreak of COVID-19 in Mexico caused several disruptions in the supply chains of medicines. The solution methodology based on a simulation optimization approach allows analyzing impacts of the different recovery strategies for a subsequent epidemiological outbreak. Additionally, the proposed approach allows enable a comprehensive view of the supply network, as well as fast and efficient response to risk situation and change. Mexico has great health challenges. It's going through a tough demographic and epidemiological transition where chronic degenerative diseases predominate. The public sector medicine supply chain in Mexico has several structural problems related to the characteristics of the health system. In 2018, the percent of a full supply of medication represented 70%, historically maintaining a percent of prescription not filled, which implies that the patient must expend out-of-pocket expenses to acquire their medication or not take treatment. In this context, the need for a supply chain for medicine and supply that allows dealing with external events such as a pandemic is evident. For this, it is necessary to take into account innovative concepts of supply chain management, simulation, risk analysis, and optimization. Being able to have robust and efficient design will allow us to react quickly to a contingent. And this is the reference. And thanks for listening. And this is my presentation. And thanks everybody. And this is all. Thanks.
Hello everyone, I am Professor Roman Rodriguez and I am from Mexico. It's a pleasure to be at the COMPSE 2020 conference. The title of the article to be presented is Application of Spectral Clustering for the Detection of High Priority Areas of Attention for COVID-19 in Mexico. The structure of the presentation is as follows. First, we will address the background of the problem to be treated, then the sources of information and the methodology used, and finally, the results and conclusions of the study. First, the background. As you know, the COVID-19 pandemic that we are currently experiencing has generated multiple effects at the health and economic level. In most countries, contingency plans were developed in the health system to meet the growing demand for health service for pandemic care. The need for more resources in health sector is evident and therefore also requires strategic planning of the allocation of these resources. An essential point is the prioritization of the susceptible population and the infected population at the regional level in the countries. In the case of Mexico, the problem is a little bit different for two reasons. First, the structure of the health system. The health system is fragmented, linked to the patient's employment situation. There are three major public health systems. IMSS, by the acronym in Spanish, is the institution linked to the population that works in the private sector. ISSSTE is the institution linked to the government workers, and INSABI serves to the rest of the open population. In addition to this condition of health system fragmented, Mexico has an extensive and dispersed territory, which complicates logistics operation to guarantee timely access to medicines and supplies in a health context like the current one. For that reason, it's necessary to define priority areas, albeit temporarily, in order to focus efforts and resources to contain the pandemic and guarantee access to medical care. For this, the objective of this research is to propose the use of an unsupervised machine learning model for the prioritization of areas of attention of COVID-19, considering fundamental elements such as the availability of human resource and infrastructure, as well as the behavior of the pandemic throughout the Mexican territory. Next, we will talk a little about the statistic registered at the time of the pandemic in Mexico. The information available as of October 2020, published by the Ministry of Health, shows a total of 1 million possible cases. A half of this total case were confirmed as a positive. The pandemic has mainly affected a higher proportion of men. In this graph, you can see the total cases by women and men, and by the test for COVID-19 detection and other classifications used by Ministry of Health of Mexico. Then the higher incidence of confirmed cases is observed in Mexico City, in the state of Mexico, Guanajuato, Nuevo León, and Veracruz. That's the reason because we need the methodology to prioritize the attention for the patients. These states have the highest number of confirmed cases, and these 5 states account around the half of total confirmed cases throughout the country. If we analyze the mortality by age groups, we can see the more vulnerable groups are the groups over 60 years, with an average rate of 407 deaths per 1,000 inhabitants. The lowest mortality rates are found in young population, with an average of 14 deaths per 1,000 inhabitants. Now, let's see the data and the methodology used. The information used corresponds to last available cutoff regarding resource and infrastructure. Additionally, corresponding variables were integrated to the evolution of the pandemic, for which there are records from January to October 2020. The variable considered in 5 dimensions of analysis, we consider the total public spending on health, doctor and nurse in contact with the patient, medical units, beds in the hospitalization area, intensive care units, hospital discharge, non-communicable disease discharge, COVID-19 positive cases, and COVID-19 deaths. With this information, we applied the spectral clustering methodology. This methodology uses a similarity measure as main input. Similarity measure is less restrictive than a distance measure. Many methodologies of clustering use a distance measure, but in this case, the use of similarity measure allows generating more flexible cluster. The spectral clustering method uses the information from the data similarity matrix to perform the dimensionality reduction. Using the similarity matrix as input, each pair of points in the dataset is evaluated. This methodology considers that the points to be grouped are not part of a space vector. The variables to consider or the attributes are incorporated in a single dimension. The similarity, which takes a numerical value for each pair of points. Given a set of data, the similarity matrix can be defined as a symmetric matrix that represents a measure of similarity between data points. The general approach for spectral clustering is to use a standard clustering method. For example, k-means or k-medoids on relevant eigenvectors of Laplacian matrix or matrix A. Based on the information captured by the similarity matrix and the Laplacian matrix, the main objective of the spectral cluster is to project the information in a space of less dimension where the segmentation of the groups is natural and allows groups to be adjusted to unconventional forms. This is the main characteristic because we chose the spectral clustering methodology. Now we can see the algorithm of spectral clustering. This algorithm is very simple, only has 4 steps. The first steps consist in transform the matrix A. Remember, the matrix A is the similarity matrix. This similarity matrix is transformed to a transition matrix, a P matrix, that this transition matrix is used to estimate the agent decomposition for estimate the K principal subspaces. With these principal subspaces selected for the agent decomposition from the transformation matrix P from the similarity matrix A, we can run any methodology of clustering, any algorithm of clustering, and get the groups selected by the algorithm. The main results of the application of this methodology are the following. In this graph, we can see the eigenvalues of each eigenvector of the Laplacian graph. We can see that in this case, the largest gap is between the eigenvectors 2 and 3. So, using the methodology, we can select a number of partitions, the variable k, and maybe we can use 4 partitions. In this case, we select 3 partitions. Because 3 partitions? Because we want to use this clustering to consider this cluster as monitoring semaphore in terms of selecting those states that represent the highest priority. This is the prioritization objective. Now, the first three-dimensional eigenvectors of the spectral decomposition will be used to run the K-means algorithm with 3 partitions. With the information generated from the spectral cluster, 3 partitions were generated using a K-means algorithm, and we use the t-distribute stochastic neighbor embedding algorithm to represent the spectral decomposition in a 3-dimension space. As we can see, we have 3 groups separated by 3 colors, and it's very clear the segmentation using the spectral clustering. The results show in 3 groups the states with the highest incidence and mortality in COVID-19. These states present problems of resource availability as well as high values in associated disease as a risk factor. We have 3 clusters. Each cluster corresponds a group of states of Mexico, and the color represents the color of semaphore to prioritize the risk and the need of resources of each group. For example, group 1 corresponds to the states with lower risk. These are states with low health resource, but also with low incidence and deaths from COVID-19. Group 2 corresponds to the largest states that in turn concentrate greater resource in health and greater risk related to chronic non-communicable diseases. In addition to presenting the highest incidence and deaths from COVID-19. This is the main group that need resources and need attention for the Ministry of Health. The group 3 corresponds to states with lower risk with moderate health resource, as well as confirmed patients and deaths from COVID-19. Now, the main conclusion of the research will be the following. First, as you know, the pandemic that we are currently experiencing has generated the need to propose and implement innovative ideas for its management and attention to the problems related to the attention of COVID-19. Mexico is no exception since the rate of infections and deaths has been increasing since the first months. A fundamental element for the correct management and overcoming of this crisis is the efficient and timely allocation of health resources that allow to face this crisis. The application of a spectral clustering model makes it possible to address the grouping of states in Mexico, allowing the integration of structures with unconventional borders. By projecting an n-dimensional space in a low-dimensional space through the use of the similarity matrix and the Laplace matrix. The results generated show congruence. 3 groups are identified based on the availability of health resource as well as the risk due to the growing demand for medical care and deaths from COVID-19. Identifying the priority states will allow a more efficient and targeted allocation of resources to be able to act strategically in the face to the current contingency. The results can serve as antecedent for a much more disaggregated grouping and with a greater number of variables that allow the allocation of resources to be focused even more. However, it's necessary to have detailed information in timely manner to achieve this goal. As you can see, the application is very simple but very powerful and helpful for this crisis in Mexico. Well, I appreciate your attention and I leave my email for any question or any comments about the paper. Thank you very much for your attention.
Hello everyone, my name is Ana Paula Yañez Brand and I'm exposing you the develop of a project that we have done in a Mexican hospital. The name is Identifying the Main Causes of Medical Devices Failures While Surgery at High Specialization Hospital Implementing Lean Six Sigma. Well, first, the Mexican healthcare system is divided into sectors, the private and the public one, and has three levels. The first level protects the health in the first touch with the patient. The second level provides basic specialties in general or specialty hospitals and has diagnosis and laboratories. But the third level provides the specialized attention in the country, and teaching and research are done here. So we are focuses in the National Institute of Rehabilitation, and we have the public and the third level. Well, quality in healthcare system. Quality is defined as a direct correlation between the level of improved health services and the desired health outcomes of the individuals, and the quality improvement is the systematic and continuous action that leads us to a measurable improvement in healthcare. And this quality improvement had 6 attributes: security, efficiency, efficacy, focus on the person, equity, accessibility, opportunity, and affordability. So, Lean Six Sigma. Lean focus and looks for a way to improve and optimize the product system, trying to reduce all the activities that not add value to our product. And this is identifying our 8 ways: transport, inventory, motion, underrated skills, waiting, overproduction, overprocess, and defects. And Lean Six Sigma aims to improve by finding and eliminating the causes of mistakes and defects in business process. The methodology has 5 steps: define, measure, analyze, improve, and control. So, Lean Six Sigma is the basis of strategy of the MIC used to reduce the errors and Lean to optimize process and improving them. So, Lean Six Sigma in healthcare, this is what some authors have said. For example, Lean Six Sigma has the power to save millions of dollars in healthcare by combining its key components with the major principles of Lean. It's a viable approach to not only reduce costs but also improve quality in the organizations. So, looking in the papers that have been done all around the world, I found one which it's a study done in three databases. They look for with criteria bases that the papers must coincident with Lean Six Sigma, any of these, and medical care, hospital, or research. They eliminate redundancies and keep 120 studies. The conclusion are these: 22% of all these studies are represented by Lean Six Sigma, 7% of the studies were done at operating rooms, 21 countries were found in these studies, but Mexico was not found. So, looking for the state in Mexico, I found this article of one group of Mexican researchers. They did a survey in 30 Mexican hospitals at 6 states with 260 participants, and the conclusions were that 60% of these hospitals have considering or have done some implementation of Lean Six Sigma, but it's not considered if they have not published. So, and it's equally used in the public and private hospitals. So, medical devices are used daily in the work of physicians, and they are helpful because they can give us a better diagnosis, greatest treatment, and help successfully with patients' recovery. But what happens if these medical devices fails? Well, in the industry field, if a machine does not work in the right way, we have like different consequences: waiting time, loss of client satisfaction, defects, money loss. We have to remember that it's a material that goes through a process and finally gets converted into a product and goes to a client. But in the healthcare system, we have a complex system. It's a human test where a client or our patient flows through the process asking for quality services, and it has to be the best possible that we can give to them. So it's important to upgrade the quality improvement all the time. So we find an area opportunity to implement Lean Six Sigma where to avoid the medical devices failures. So we decided an important area is the operating rooms. So the contribution will be, well, first of all, quality research in the Mexican field, and academic impact is that we will going to start creating literature like the actual system is shown, barriers are explained, methodologies are exposed, and conclusions are shared. So let's focus in the modulation of this problem. Well, first we have the biomedical engineer department who is in charge to the maintenance of all medical devices, preventive and corrective. The CIM, it's a system where the biomedical engineer department puts all the service orders that have been done in all the medical devices in the hospital. The hospital has two surgical units, human communication and orthopedic, and the first have 3 operating rooms for ophthalmology and 3 operating rooms for otolaryngology, and the orthopedic have 10 operating rooms. The methodology that we decide to use is the first steps of the MIC to get conclusions. We're going to finish in this stage for this project. And define first a 5S diagnosis to know the actual state, then a thread diagram, interviews. That interviews will generate brainstorms, and with this brainstorm, we're going to do a problem selection, content frequencies, and with these frequencies, we can do a brainstorm Pareto chart. And with all the order services from the CIM, we did another Pareto chart. For the measure step, we do a value stream map, and for the analyze a YY. First, in the orthopedic surgical unit, well, the 5S diagnosis shows a formal achievement. The Pareto chart of CIM shows that the 20 vitals were the steam sterilizers, but these are at the sterilization center, so it's not precisely in operating rooms. So we're going to indicate in another tools. The Pareto chart of brainstorm shows that the 20% of the mistakes are caused by mistakes using these medical devices. In the measure part of the orthopedic surgical unit, well, we have this value stream map where the patients flow through this process, and finally we have a patient also, but we focus, well, the surgery project, it's with the biomedical engineer when he arrives to the surgical unit and he checked the reports about all the failures or incidents in medical devices. We have the two first casing outputs. Some medical devices are not reported, and the external provider engineer is absent. Then he, by himself, has to check and prepare all the 10 operating rooms. Then we have the second output, that is when a medical device failure, that is the corrective maintenance. And when we analyze the first cause of the Pareto on the brainstorm, the 20%, we have the mistakes used in medical devices. Why? Maybe it's by accident, but oversight, lack of awareness, and not being measured the implemented. Handle wrong the medical device. Why? The user does not know how to transfer it through the surgical unit, the lack of experience, because of a lack of training, because non-attendance to the user area to this training. And also it could be because the user is careless, because the lack of training, the user doesn't know how it's the complexity of medical device, doesn't know how function and how to keep it, and this leads to the not attention to the user training. Then mishandled by the user, don't know the principles of operation, lack of training, user's absence of training, or lack of experience, lack of training, user is new and school schedule. This is because of the residents who are new in the hospital. So we can see all of this divert to the non-attendance by user to training in the orthopedic surgical unit. Then, in the human communication, we implemented same tools. In the 5S diagnosis, we got a formal achievement. For the thread diagram was shown a lot of ways of transportation and movement. The interviews, brainstorm, problem selection, and Pareto brainstorm, we have the area planning that it explains the waste of transportation, but we have to say that this is not, or it could be considering in the goals of this project, so we can focus on the following one, which is also mistakes using medical devices. Then the Pareto charts of the order services at the CIM, the ophthalmology have electrosurgery units, and the otorhinolaryngology is the steam sterilizer. This medical device is used at the beginning of every surgical procedure, so we can add to the work routine of the biomedical engineer to do maintenance. Okay, then the value stream map shows you the same process. In surgery, we have more output of casing. First is the transport that has been already mentioned, the medical devices that have not been reported, and the external provider absence, but we have two providers in here, so it's an overload of work to the biomedical engineer. And then we have another two casing outputs, medical device failures and transport. So if we analyze, we have the same in mistakes using medical devices and the same divergency to non-attendance user to training. So results, we have the non-attendance by user to training. That's the main cause, but we dig in a little bit more and we find out that in the hospital regulatory framework stipulates that annually a survey will be done to detect training needs. The biomedical engineer department will establish with the department head the training needed, and if the department of the hospital needs training, it must be solicited to the department. So this training service exists, but the user does not require them or does not attend them. So this is like the main point that we identified that we can focus on to solve the medical devices failures while surgery. Then the conclusion, well, we have already said it. The main causes that the produces medical devices failures at surgical unit at the institute has been identified as the lack of training and the no participation of the user on it. So we strongly recommend start participating to avoid these failures, and to understand the economic impact, it's important. We are talking about a public hospital, so if the situation continues in the same way, the hospital will be continue paying for this maintenance to external providers. But if the user start to participate in these trainings, there will be no extra expenditure, because this like expenditure it's included in the biomedical engineer department work routine, so there will be no extra charge. If we continue with the following stage of the MAC methodology, we have implementation and control. These steps, we propose that also have been measured, reported, and to do the respective investigation with all these papers, because like it's something new in our country. All the conclusions that we get will be important and could be like the starting point to another researchers to start doing this quality job that it's very important. Now let's quote the National Association of Faculties and Schools of Engineering. The design of a society that meets new needs in field of health and highlighted the requirements of engineer to face it, so medical technology develops holistic and complex intervention system in which engineer will certainly also play an important role. And well, we are this investigation, this is our team, and this is our reference. So now we're going to follow to the question and answer session. Thank you so much.
Hello, the topic of this presentation is MTGWA, a multithreaded gray wolf algorithm with strategies based on simulated annealing and genetic algorithms. So, the paper presents an improvement of meta-heuristic optimization algorithm called the gray wolf algorithm that mimics the behavior of gray wolves in nature. This optimizer was introduced by Mirjulili in 2014. Meta-heuristic algorithms have become popular methods for solving problems for four main reasons: simplicity, flexibility, derivation-free mechanism, and optimal local avoidance. They also have been mostly inspired by concepts related to physical phenomena, natural phenomena, and animal behaviors. The meta-heuristic algorithms can be divided into two main classes: those based on a single solution, such as simulated annealing, and population-based solutions, like Firefly optimization algorithm. In the single solution-based search processes, there is a unique candidate solution that improves throughout the iterations. By the contrary, the population-based meta-heuristic uses a set of random initial solutions called population, that also improves for each iteration. But they also can share information between each candidate of the population that provokes unsudden leaps towards better results and cooperation to avoid local optimums. Finally, having more candidates results in better exploration of the search space. Population-based meta-heuristic have a branch known as swarm intelligence (SI). Swarm intelligence algorithms divide the search process into two phases: exploration and exploitation. As it is shown on the images, the exploration phase refers to the research process of the promising areas of the search space, and the exploitation phase refers to the search capacity in the promising regions obtained in the exploration phase. As we said before, this paper presents parallel implementations to improve the nature-based meta-heuristic optimization algorithm called gray wolf algorithm that mimics the behavior of gray wolves. So, to understand this algorithm, we need to understand the behaviors of gray wolves. Gray wolves are considered top predators of the food chain. They mostly prefer to live in a herd of size with 5 to 12 wolves on average. And these herds have a rigorous dominant social hierarchy. The leaders are called alphas, and they are responsible for making decisions about hunting, sleeping place, waking times, and so on. The second level in the hierarchy is beta. The betas give orders too, but to the lower levels. They help the alphas in the decision making and other activities. The next level is called delta. They have the function of scouts and sentries. And finally, the lesser gray wolf is omega. They maintain the structure of the dominion and care of the young. In addition to the social hierarchy of wolves mentioned, wolf hunting is another interesting social behavior of gray wolves. The main phases of gray wolf hunt are: first, the actions of tracking and chasing to approach the dam. Then they pursue, surround, and harass the dam until it stops, to make distinctive movements to surround it. And finally, wolves attack their prey. And gray wolf algorithm models the behaviors of the hunting and social hierarchy to perform the optimization. To model the social hierarchy of wolves, we consider that the alpha wolf XA is the one in the position with the best fitness of a function to optimize in each iteration. The second and third best solutions are named beta wolf and delta wolf respectively. And the remaining wolves update their position considering the position of the alpha, betas, and delta wolves. To model the hunting behavior, the global optimum can be considered as the prey. As it is not known the location of the prey, it can be assumed that the alpha is closer to the prey. Remember that the alpha is the one that is having the best fitness value on each iteration. Random parameters vector A and vector C help the population to have hyperspheres with different random radii for the search space exploration process. And also, the small a vector allows a smooth transition between exploration and exploitation. The multithreaded implementation starts with the initialization of 4 new parameters. n_GW, the number of gray wolves by each thread, p, that indicates the number of iterations in each thread before the implementation of a crossover technique, max iter, that indicates the total number of iterations that each thread is going to execute, and sbest, that is the best solution obtained of all threads. The multithreaded implementation executes independent versions of the gray wolf algorithm on each thread until the number of iterations in each thread reaches the cutoff value p. Then the best of all solution is obtained. Once this is done, the crossover techniques are executed. This process is repeated until the final generation, when the maximum number of iterations is reached. In this paper, 4 crossover techniques were implemented. Restart to the best, TB being the easiest to implement. This crossover method takes the thread with the best solution, sbest, and copies the value obtained for all other threads. Then we have annealing to the best. Similar to the simulated annealing algorithm, copies the best solution only when a random number is lower to the annealing equation that uses the number of iterations as the time unit. As it is shown on this bar graph, the probability of restarting to the best will decrease gradually after each iteration. Then, genetic with the best GTB is inspired by the procedures of genetic algorithm. A random number of positional values of the best threads are mixed with the results of each of the remaining threads, as it is shown on the image. And finally, annealing genetic with the best AGTB. As the name suggests, this method combines the previous 2 techniques, genetic to the best and annealing to the best. If the annealing equation is met, then it proceeds to execute the combination of the best solution with the remaining threads. To evaluate the performance and effectiveness of the algorithm with different parameters, we benchmarked the algorithm with 29 different functions. Some of them were unimodal, multimodal, fixed dimension multimodal, and composite functions, having a total of 29 different functions. And all non-fixed dimension benchmark functions were set to a 30-dimensional space. For the unimodal benchmark functions, we used the sphere function, that is the one represented in the figure, also the Schriefel 2.22 function, the rotated hyperellipsoid function, the Schriefel 2.21 function, the Rosenbrock, the STIP2, and the quadratic with noise functions. To evaluate the multimodal functions, we use the Schriefel function, the ray string, the Ackley one, the Greenwag, that is the function that is shown on the figure of multimodal functions, the generalized penalized one, and the generalized penalized 2. Then, for multimodal with fixed dimension, we use the Schickel-Foxhall, the Kowalik function that is shown in the figure. Kowalik function is a 4D function. This is a 2D representation of the function. Also, the 6-hump camel, the Brainly number 1, the Goldstein price, Harman 3D and Harman 6D functions, and shekel 4.5, shekel 4.7, and shekel 4.10 functions. And to evaluate the performance of composite functions, we equaled some of the listed functions and the Weierstrass function using other of these functions as parameters, as it is shown in the table. We developed the algorithm in C#, and in order to tune the algorithm parameters, we executed it 30 times with each of the 13 selected multimodal and unimodal functions, and found that p equal to 100 gave the best results in average. Also, by using a 4-core CPU like the i7-8550U from Intel, we determined that the use of 6, 7, and 8 threads for the crossover variants were the best performing ones without affecting the execution time. But as a general rule, more threads equal better quality results, because the amount of threads is directly proportional to the number of wolves. This rule is illustrated on the graph, where we normalized and invert the fitness results with different threads. After tuning the cutoff value of p and the optimum number of threads due to our hardware limitations, we can proceed to show the multi-threaded implementation with the different 4 crossovers techniques. This first table shows the comparison between the original single-threaded gray wolf algorithm and the proposed parallel implementations in the 29 selected functions. The column of GWO is the original algorithm, and the rest of the columns are the results we obtained using the parallel implementations. For the unimodal functions, we can observe that the better results were obtained in all functions using the crossover techniques. Furthermore, in step 2 and quartic with nose benchmark functions, the exact minimum 0 was obtained. Experiments with multimodal functions also show better results for our algorithms. For multimodal functions of fixed dimensions, the results reached the minimum expected values except in 3 functions: the Harman 6D, shekel 4.5, and shekel 4.10 functions. The execution with composite functions showed that our algorithm was better in 4 functions of the 6 tested. Now, this second table presents the result obtained with 7 threads. As you might saw between the previous graph and this one, the results with using Annealing genetic with the best improved. Finally, this table presents the results obtained with 8 threads, obtaining the best quality solutions on average, as expected. As it can be visually seen from the graph at the right, and from the previous 2 graphs, the genetic restart to the best crossover technique gave the best solution in most of the benchmark functions. Also, the annealing restart to the best was never the best performing solution for the composite functions. But the hybridization of this technique and the genetic restart, named as annealing genetic with the best method, improves the quality of the result, having a more balanced approach due to the implementation of the other 3 techniques. In conclusion, meteoristic optimization algorithms can take advantage of the hardware architecture improvement found in modern CPUs. Using a multi-core CPU gives us the ability to run multiple threads without affecting the execution time that can be crucial for some processes. The use of multiple threads allows us to generate many heads at the same time, in other words, a larger population. Our experiments show that the multi-threaded implementation of the gray wolf optimization algorithm achieves solutions closer to the absolute minimum or even equal to it. Finally, it was proven that sharing information between threads, such as restarting techniques, every certain amount of iterations help the algorithm to improve the quality of the solution. Thank you.
Effectiveness of some tests of spatial randomness in the detection of weak graphical passwords in Passpoint. This paper explores the usability of the right-place phi-function and the nearest neighbor distance in the detection of clustered graphical passwords in the graphical authentication stage. Both tests were applied from two databases of 10,000 cluster graphical passwords each. The first with graphical passwords clustered in an area lesser than the fourth part of the original image. The second clustered in an area lesser than the eighth part of the image. The results show that none of these tests is effective in the detection of cluster graphical passwords. It is our opinion the reason of such failure is due to the short size of the spatial pattern in questions. Only the 5 points of the graphical password analyzed. Graphical passwords are an important alternative to traditional alphanumeric passwords. The Passpoint is of special interest among the graphical authentication techniques. The 5 points selected as graphical passwords must follow a random pattern, otherwise they are considered weak passwords. It is therefore of importance to have a tool that warns the user during the registration phase about a possible graphical password with poor randomness. The dataset generated by the coordinates of phenomena that occurs in the specific region of space is named the spatial point pattern. There are three characteristic patterns: random, grouped, regular. In point pattern analysis, it is assumed as a null hypothesis that the pattern of points presents a complete spatial random distribution CSR. The alternative hypotheses are the cluster and the regular distribution. From the most used tests to evaluate the hypothesis of CSR, two of them are Ripley's K-function test, nearest neighbor distance test. Ripley's K-function test is a distance-based method that measures the average number of points within a circle of radius r around any point in the pattern. When applying the K-Ripley function, the decision criterion used is: a group pattern occurs when LR is over 0. A regular pattern occurs when LR minus zeros. To perform the hypothesis test with the function Kr, it is necessary to estimate the critical values. We do this through Monte Carlo simulations. This figure illustrates the decision criteria mentioned above. The nearest neighbor distance test becomes another effective method to describe the behavior of the spatial point pattern. By means of Monte Carlo simulations, the critical values of the test that allow accepting or rejecting the null hypothesis of CSR are calculated, as shown in the following figure, for each type of pattern. The precision of Ripley K-function and the nearest neighbor distances is directly proportional to n. The smallest pattern becomes the reference for which both tests were effective are 36 points. In this paper, the following question is investigated and answered. What is the effectiveness of this test in the Passpoint scenario where only 5 points are available? two databases of clustered graphic passwords were generated. Database 1, db.1, consists of 10,000 graphical passwords grouped. Database 2, db.2, consists of 10,000 graphical passwords strongly grouped. Critical values were estimated for each of the tests by 5,000 Monte Carlo simulations of 5 random points. This figure illustrates the results obtained by applying both tests to the 2,000 graphical Passpoint passwords, grouped and strongly grouped. The following table shows the percentage of clustered graphical passwords detected by each test for BD.1 and BD.2. Both tests were ineffective in detecting DB1 and DB2 sets as clustered. The experiments shows that Ripley's k-test and the nearest neighbor distance test are not effective in detecting graphical passwords grouped in the Passpoint scenario. Therefore, it is necessary to develop methods to detect clustering in graphical password for only 5 points. Our future research is directed in that sense. The results will be presented in future works. Analysis of the number of sites of Voronoi polygons in Passpoint. The probabilistic distribution of the characteristics of the Voronoi polygons has been extensively studied due to its many areas of application. Graphical passwords are an important alternative to traditional alphanumeric passwords. The Passpoint is of special interest among the graphical authentication techniques. Passpoint is based on the selection and remembered by the user of 5 points on the image selected as a password. The 5 points selected as graphical passwords must follow a random pattern, otherwise they are considered weak passwords. In this work, this characteristic in the Voronoi polygons generated by the graphical passwords of the graphical authentication system Passpoint is studied. Its distribution is estimated, and it is shown that the expected value of the number of sides of the Voronoi polygons in this scenario differs from previous works. The effectiveness of this feature is evaluated to detect weak graphical passwords made up of grouped dots. The spatial point patterns are classified as random, regular, grouped. Two of the most used tests in spatial randomness, the K-Ripley function, the distance to the nearest neighbor. They are unable to detect the presence of grouped points in the graphic passwords of Passpoint. It is necessary to develop methods to detect clustering in graphical password of only 5 points. In this work, the efficiency of the number of sides of the Voronoi polygons is investigated to detect graphical passwords with points grouped in Passpoint. The Voronoi diagrams, VP, are a geometric construction that, given a set P of n points in the plane, allows to build a partition of the Euclidean plane into a set of n disjoint regions, so that each region contains a single point, as illustrated in the figure in blue. The dual of a two-dimensional Voronoi diagram is a Delaunay triangulation, as illustrated in the figure in red. Voronoi polygons and their Delaunay triangulations have a set of characteristics determined by the properties of randomness or dependent on the initial set of points. In the two-dimensional case, the 8 characteristics of these polygons are presented here. In previous works that estimate, through simulation, the distribution of the number of sides of the Voronoi Poisson polygons, the following 2 fundamental variants are observed. The theoretical distribution of the number of sides of the Voronoi polygons, estimated in previous works, is shown in the following table. Attention to the fact that, despite being estimated in different ways, their probabilities are similar to each other and similar to those theoretically found in Calca 2002. The expected value is equal to 6 in all cases. The experiments were carried out for 2 sizes of images. In each image, 300 random graphic passwords, VD1 and VD2, were generated. A total of 1,500 Voronoi Poisson polygons were generated in each VD, and the distribution of its number n of size was estimated. Table 2 shows the probability distribution of n estimated in VD1 and VD2. The results from the table above are shown in figure 2. The similarity of the results for VD1 and VD2 is appreciated. The expected value of the number of size of the Voronoi polygons was approximately 5 for the 2 image sizes. A test based on the number of sides of the Voronoi polygons is proposed to detect clustering of points in the Passpoint graphic passwords. 3 possible critical regions are proposed. To evaluate the effectiveness of the proposed test, a new database bit3 or 300 grouped graphic passwords was generated in 1/16 of the image with a size of 1366 by 768 pixels. The proposed test was applied to each of the passwords. The results are shown in Table 4. It is observed that the effectiveness of the test is insufficient. The low effectiveness of the proposed test is explained by the overlap of the distributions of n for random and grouped passwords illustrated in Figure 3. The estimated distribution of the number n of size did not fit any known distribution. The fit to the 54 theoretical distributions supported by the EasyFit 5.6 program was measured. It is not possible to distinguish whether the points are grouped or randomly distributed, as shown in the figure, because of the overlap between the probability distributions of the number of sites. Here, you can see the difference between the results of this work and the background. This difference is due to the specific characteristics of this scenario, in particular, the generation of polygons from only 5 points in the plane. In this work, the behavior of the number of sides of the Voronoi polygons generated by graphical passwords of the Passpoint graphical authentication system was investigated. Its distribution was estimated, which could not be adjusted to any of the known distributions. It was obtained that the expected value of the number of sides of the Voronoi polygons was 5, regardless of the sizes studied. It was obtained that the distribution on the expected value of the number of sides of the Voronoi polygons in this scenario differ from previous works. The most important conclusion is that the characteristic number n of sides of the Voronoi polygons is not efficient to detect graphical password grouped in Passpoint. In future works, the efficiency of other characteristics of these polygons will be investigated.
Dear colleagues, allow me to present our joint research with my colleagues from Institute for Mechanical Engineering Problems of the National Academy of Sciences of Ukraine and Nuevo Leon State University, Mexico. Our study is devoted to modeling nanocomposites with ellipsoidal and conical inclusions using optimization packing problems. Solid-type nanocomposites have remarkable mechanical properties and are widely used in practice in many engineering structures and systems. Taking into account diversity of material components and distribution of particles, variety of shapes and arrangements of nano-inclusions, developing new models and methods to study nanocomposites is extremely important. Computational nanotechnology focuses on numerical simulation in the area, and the results are basically related to two-dimensional configurations of the objects. Concerning three-dimensional shapes, they have been analyzed mainly with the assumptions of canonical single spherical particles in the nanocomposite or spherical inclusions in the periodically structured nanomaterial. In this study we consider 3D nanocomposites that may have the shape of an ellipsoid or a cone. A cube matrix with inhomogeneity inclusions is considered. This cube matrix with the inhomogeneity may be considered as a representative volume element for studying nanocomposites' mechanical properties. The current research is devoted to elaboration of mathematical and computational models for estimating the effective modulus of nanocomposites using a representative volume element with different mechanical and geometrical characteristics. To analyze interactions of nano-inclusions in composite materials, 3D optimized packing models are used. Problem formulation. A packing problem is considered in the following setting. Let a cuboid of variable length, width, and height be given. Suppose a set of nano-inclusions, or 3D objects, is defined to be placed completely inside the cuboid without overlaps. Each nano-inclusion can take the shape of an ellipsoid or a cone. The size of each nano-inclusion is assumed to be fixed. The arrangement and orientation of each 3D object are defined by a variable vector of its placement parameters, including translation vector and rotation angles. The problem of filling nano-inclusions into the volume can be stated as the following optimization problem. Pack the collection of 3D objects fully inside the cuboid of minimal volume. The following constraints have to be met in the problem. Non-overlapping nano-inclusions and containment of nano-inclusions into the cuboid. To formalize placement constraints, the phi-function technique is used. Tools of mathematical modeling. A continuous and everywhere defined function, called a phi-function, is defined for the pair of objects. Phi-functions allow distinguishing the following three cases. Objects do not overlap, therefore do not have any common points. Objects are in contact, therefore have only common frontier points. And objects are overlapping so that they have common interior points. Phi-function depends on placement parameters of the objects. Its values are positive for the first case, equal to 0 when objects are in contact, and negative while object overlapping. When ordinary phi-functions are too complicated or have not been constructed yet, a new class of functions, called quasi-phi functions, is successfully used. These functions depend on auxiliary variables except placement parameters of the objects. To describe containment constraints, a phi function for the objects and the complement of the cuboid is constructed. This phi function may be defined as a minimum of smooth functions. We employ quasi-phi functions for analytical description of non-overlapping constraints. Let two ellipsoids with the appropriate semi-axes be defined. For each pair of ellipsoids a hyperplane is constructed. The normal vector and two rotation angles of the hyperplane are variable. We introduce a new quasi-phi function for ellipsoids that can be freely rotated and translated. To describe the non-overlapping constraint of truncated cones, we introduce a new quasi-phi function. Let two truncated cones with the appropriate dimensions be defined. Each truncated cone is defined by 3 vectors as well as a pair of parameters, including centers, and the radii of the bottom and top bases of the object and the unit normal vector to the bottom, top, base of 3D object. A quasi-phi function for truncated cones can be defined as a minimum of a phi function for the 3D object and the half space and a phi function for the object and the complement to the half space. Mathematical model of the packing problem. The vector of all variables of the packing problem includes the vector of variable dimensions of the container, the vector of placement parameters for 3D objects and the vector of auxiliary variables for quasi-phi functions. A mathematical model of the optimized packing problem may be stated in the form of non-convex continuous nonlinear programming problem, where the feasible region is described by the system of quasi-phi function inequalities defined for each pair of 3D objects aimed to describe the non-overlapping constraints, and the phi function inequalities enforcing the containment constraints. Each phi function inequality in the solution space is presented by a system of inequalities with differentiable functions. The model is an exact formulation for the optimized packing problem. A solution strategy. The proposed multi-start solution strategy involves 3 main stages. Stage 1. Generate a number of starting points feasible to the stated problem. The homothetic transformations of objects are used to construct feasible solutions. The algorithm has the following steps. Step 1. Choose a sufficiently large container. Step 2. Circumscribe each 3D object by the sphere. Step 3. Generate randomly in the large container a set of n centers for the spheres. Step 4. Scale all the spheres to the full size by solving an auxiliary nonlinear programming subproblem. Step 5. Form a vector of feasible translation parameters for each of nano-inclusions. Step 6. Generate randomly rotation parameters for each 3D object. Step 7. Construct a point feasible to the stated problem. Stage 2. Search for a local minimum of the problem starting from each point obtained at stage 1. Here the optimization procedure for large-scale packing problems is used. This decomposition algorithm reduces the large-scale problem to a sequence of nonlinear programming subproblems of considerably smaller dimensions. Stage 3. Choose the best local minimum from those obtained at stage 2 and consider it as a solution to the packing problem. Computational results. 3 problem instances are presented below to illustrate the work of the proposed multi-start approach. To solve NLP subproblems, the IPOPT code is used. Example 1. Packing 35 conical nano-inclusions. The corresponding local optimal packing is shown in Figure 1. Example 2. Packing 40 conical nano-inclusions. The corresponding local optimal packing is shown in Figure 2. Example 3. Packing 100 ellipsoidal nano-inclusions. The corresponding local optimal packing is shown in Figure 3. Concluding remarks. In this work, novel mathematical models of representative volume elements with different geometrical characteristics are proposed. To represent mutual interactions of nano-inclusions in composite materials, 3D optimized packing models are developed. Numerical examples are presented to illustrate the usefulness of the approach. Using numerical modeling instead of expensive full-scale experiments facilitates synthesis of nanocomposites with desired properties. Convex, regular, shapes, ellipsoids and truncated cones, were used in this work to represent the composite matrix and nanoequations in packing models. However, in many practical cases nano-inclusions may have irregular shapes or can be represented as a composition of regular shapes. An interesting direction for the future research is using the approach based on covering complex objects by more simple shapes or applying other original ideas for placement conditions. Acknowledgement. Tatyana Romanova, Alexander Pankratov, and Elena Strelnkova were partially supported by the Program for the State Priority Scientific Research and Technological, Experimental Development of the Department of Physical and Technical Problems of Energy of the National Academy of Sciences of Ukraine. Thank you for your kind attention.
Hello everyone, my name is Maria del Carmen Toledo, a student of Mechanical and Electric Engineer College at the Autonomous University of Nuevo León. The suggested topic of this study is Design Strategy for University Education Supply Chain. The content for this study includes an introduction to the subject. It is also intended to make an analysis of the proposed methodology. We will see the result obtained from this research, and finally, the conclusion. In time, when the competency-based approach becomes more complete and requires special training for teachers and students, equality and well-structured education is required that entails a society of excellence. That is why managers, leaders, and stakeholders of the university education institution seek to incorporate supply chain concepts into education environment as a strategy that allows them to improve the flow in educational process. The university education institution represents a key element that helps drive the economic and social development of each nation. However, there are aspects of concern that require strategy and that represent a challenge for today's higher education, among which the following stand out. The phenomenon of massification and universalization. A report issued by the OECD in 2015 graphically showed what this increase has been like in 38 countries over a period of more than 10 years, and it can be seen that from 2000 to 2012, the increase has been little more than 10%. On the other hand, as a problem situation, we have the limited financing that is destined to improve education programs. This makes universities increasingly inefficient and internally focused, forcing them to establish new strategies for managing their resource and educational service. And the three limiting elements, we have the lack of communication between the university education sector and the labor market, which causes the curriculum currently in place not to meet the needs of the application. This situation demands an improvement in the administrative and operational process of the university education sector, requiring the incorporation of supply chain approaches in the work strategy of these institutions, which allow them to meet the increasingly growing demand, meet the quality market requirements, and also better manage their resources. To this end, a methodology framework is proposed that allows either a flying supply chain design strategy that can be used in the university education sector and that help improve educational process and that also allow to increase the competitiveness of university in each world more global. The methodology consists of three stages we are explaining below. Stage 1. Planning and selection of documents. Begin with a planning review of documents required for the development of this study, which allow the selection of jobs related to the university educational supply chain and supply chain design strategy. Using for them the renowned database Scopus, ESCO, Elsevier, El Cielo, and others. A total of approximately 251 documents are reviewed, which are divided into 26 documents related to general supply chain concepts, 191 relate to educational supply chain, and 34 relate supply chain design strategy. The revised documents serve to conceptualize educational institutions as a supply chain, highlighting the concept held by Habib and Hassan 2019, who cite that the university educational supply chain is the integrated set of the educational supply chain and the research supply chain, and the has its peculiarity is to wide sense in which information and service flow are a single level of management the chain. This is because the consumer or customer become the one who provide information and input the chain to achieve quality graduate and research of research projects. The concept of educational supply chain is an issue of interest to many authors, unlike other supply chains, require the coordination of all their nodes to achieve an aligning flow to information production and distribution. In the first stage of the methodology, it is also intended to know the supply chain design strategy analyzed by different authors. According to Meleni, Narashima, and De Campo, 2014, supply chain design is a process of development, implementation, and management of resources, process, and information which seek to make the strategic objectives of any institution or company are achievable over time. The document consulted during the stage review various design strategies used to solve certain problems, among which stand out causal loop diagrams, simulation, value stream mapping, score model, optimization, quality function deployment, Deming sequence, among others. Can know the basic concept for this study, we proceed to the second stage of the proposed methodology, which the criteria take into account by the different authors are identified when selecting a supply chain design tool and strategy from them and taking into account the characteristics and needs of the university education supply chain are established indicators that allow to select the best tool for the environment understood. Supply chain design strategies are generally aimed at solving problems related to the localization of facilities, installed capacity, the current market situation, the selection of supply chain, among others. Something that should be borne in mind in this study is that the supply chain design strategy applied in acquired environment does not necessarily generate the same result when applied in another chain with a different characteristics. So it is necessary to identify those elements that characterize H2 and other objectives proposed when applying. At this stage, we can see that identify each of the tools analyzed, and among them, we can see that the business model is characterized by being a tool that allows modeling the structure of the supply chain. The causal loop diagram allows to visualize the behavior of indicators in the supply chain. The simulation contributes to decision-making in improvement strategy and also allows to visualize behavior of different scenarios in the supply chain. Value stream mapping allows to determining limiting operation and also allows to establish a strategy for improvement. The score model is characterized by being a process reengineering tools which allow comparative evaluation of the supply chain with others. The mean cycle is characterized by allowing to establish continuous improvement from the analysis of indicators in the supply chain. The optimization allows the aligning of the strategy with the supply chain. The My tool allows to define the indicator in the supply chain process. As mentioned above, the correct design of the university education supply chain depends to a large extent on the type of design strategy that is selected for modeling, and for its selection criteria are established to make the decision. These criteria are established based on the basis of the characteristics that define each tool and also consider the characteristics and needs present by the university education supply chain. The tools selected for university education and supply chain design must be flexible and adaptable to the education environment. It should contribute to the design and improvement in process, should establish measurement parameters that allow to compare its result in the shortest possible time, and last and not least should be tool capable of providing continuous improvement strategy to the analyzed chain. Value stream mapping is the instrument that meets the most criteria, followed by score, model, and simulation. Finally, the three stages summarize the supply chain design strategy in the previous stage and highlight the benefits and limitations that the implementation of it in the university education supply chain can bring. This analysis serves to establish a reference for administrators and people interested in strengthening the strategy and integration of each of the links that comprise the university educational supply chain. Value stream mapping is a lean manufacturing management tool which allows you to visualize the processes that are carried out with any organization, showing the current state of the company, identify its point of environment and service has contribution of comparison during the implementation of any of the lean manufacturing tools. Morlock and Meyer, 2015, highlighted that the value stream mapping model worked in both manufacturing and service companies, and Washington, 2018, highlighted that these tools can also be adapted and implemented in the university education environment. The application of this model helps to visualize the global process, allowing an integrated vision of the actual operation of the chain and from the point of view of the clients also allowed to see the loss that arise in the process, allowed to link the connection between the materials and flow of information, help the aligning for the organization, and allow to establish a common language for the interpretation of manufacturing process. Among the limitations present by the application the institution, problems when monitoring process, lack of knowledge of the model by the staff within the institution, little integration between the process of the entire supply chain, wide range of products and production flow that are not yet clearly defined by the institution, lack of support from top management. Supply chain operation reference model was developed in 1996 by the Supply Chain Council in order to create a standard that allows companies to improve their supply chain operation. According to Wang, Chan, and Pauline, Rashid, and Weston, a score can be used to describe everything from simple supply chain to complete supply chain, based on its common language for process description, process performance indicators, improvement practices, and technology. A scored model is beneficial company. It allows considerable improvement in supply chain process, also allows to continue using the technology tool that the company has, being a standard model with process standardized metrics, and standardized best practice. It's flexible and easy to configure to the particularity that each business, company, or institution present, allowed to integrate its process, establish performance indicator, and thus compare its performance with other companies of similar nature. Some of the limitations present by the score model is that it does not attempt to describe each business process or activity. In addition, the model does not contemplate what is related to the process of demand generation, not development of the product, nor research and development, and has for human resource training, system administration, and quality assurance activity, a score does not consider them anymore if they should be considered when applying this model. Simulation modeling has been widely implemented in many disciplines to replicate and predict behavior, identify gaps between actual performance and the current state of the supply chain. The literature review has shown how the simulation model has been combined with other supply chain design strategies for better results in the implementation of changes and improvement strategy in the organization. Simulation in conjunction with the value stream mapping model allows to see in clear, faster, and more feasible way the limit operation which affect the current and future state of the value map in the supply chain. On the other hand, it was found in the literature that most students that use simulation in conjunction with the score model focus on problem solving and apply it fundamentally in the improvement plan process that level 4 of the model, serving as a validation instrument for decision making. The truth is that simulation not only makes testing ideas easier, cheaper, and faster, but also provides an immediate evaluation of the proposed change in the system. Despite being a very useful tool for supply chain modeling, it presents some limitations such as the lack of systematization and monitoring of the information, which make the design process lose its value and the results that are obtained are not the most appropriate. As a conclusion to this study, we can say that the university educational supply chain study is of interest to many others, and others must study focus their attention on the manufacturing supply chain. Other focus finding strategies that help analyze educational process in detail and make it possible to develop initiatives to redesign your supply chain. The literature review also reveals supply chain design strategies that can be applied to university educational institutions, include the reference model of supply chain operation, the value stream mapping, and simulation. The implementation of this supply chain design strategy in education institutions contribute to increasing efficiency and effectiveness of the service and products offered by different education institutions. This study contributes to the knowledge on the use of university education supply chain design methods and strategies, a topic later addressed in the literature. Future work could be expanded to further analyze the impact of some of these design models on university education institutions. This could help demonstrate that supply chain design strategies contribute to an improvement across their art supply chain, enabling them to meet the needs of today's markets. These are some the reference bibliography. Thanks for your attention.
Good morning, everyone. We are going to present in this conference the work titled Teaching of TCP Fundamental Operations Using a Digital Tool. The authors of this work are Ilse Alicia López Pedrosa and Francisco de Asís López Fuentes from Universidad Autónoma Metropolitana, Unidad Guajimalpa. Our main motivation for doing this work is the importance of didactic tools in teaching is reflected worldwide, and it has already been accepted as a complement to the information given by teachers. Transmission Control Protocol (TCP) is a very important protocol in the communication networks. A digital tool can help to students to acquire, reinforce, and exercise their knowledge about this important protocol. Animations and interactive examples can be useful to guide the users through a digital tool. Now, we will give you our agenda for this talk. I continue with the objectives. After this, I will explain the design, implementation, and evaluation of our proposed system. I finish this talk with the conclusions and future work. The general objective is develop a teaching tool based on animation and interactive examples that allows teaching and learning the transmission control protocol. Our specific objectives are the animation of the following TCP functions: TCP connection establishment, retransmission, sliding window. Our design is based on a web system which should be easy to access and use by the main actors, students and teachers. Our didactic tool has been mainly developed using HTML and CSS language. PowerPoint and Scratch were used for the animation and examples. We use HTML to develop the system structure. The main menu was developed to display a submenu which shows the different options, definition, and example for each TCP function. We use CSS to define the colors and the font. The main page shows the TCP definition and general information about this protocol. There is also a glossary with some technical terms that are used throughout the system. This page has a menu with 3 different options. Using this menu, user can go to the sections TCP connection establishment, retransmission, and sliding window. When we clicking on grading, retransmission, or sliding window, it will show us a submenu which contains the definition and example options. The TCP connection establishment definition page shows a general definition of how this function of the TCP protocol works. Within this same page, we can find an animation with a specific example that helps to reinforce the information presented in the text of the definition. This animation was made in PowerPoint. On the example page, you can see an animation that interacts with the user. This animation was made in Scratch, where we can see part of the code and the actors within the functions of the TCP protocol, the sender and the receiver. This interactive animation shows us if the connection establishment is successful or unsuccessful. The retransmission definition page also shows a brief definition of this protocol function and an animation exemplifying what is described in this definition. The example page of the retransmission shows the interactive animation where, depending on the time stipulated by the user, it is possible to see the number of times necessary how the retransmission is performed within the TCP protocol. This section was made in Scratch. The sliding window page contains a brief definition of the protocol and an animation exemplifying what is described in the definition. The example page of the sliding window was made in Scratch and interactively shows the general characteristics of this function of the TCP protocol. A characteristic of the system is that simple animations were used instead of images for a better understanding, since they explained step by step the process of the functions. The animations were made in PowerPoint presentations. The idea of making animation in this way arises from seeing that through PowerPoint presentations the figures can be made, adding movements and more visual effects that help to understand the subject, obtaining as a result simple, understandable, and easy to use animations that can be viewed, stopped, restarted, or advanced so that the user can see it as a more interactive method than images. Our didactic tool was tested with some users to evaluate its performance. Main questions were to highlight the design of the system and how this information was useful to them. The responses were very homogeneous since most of them had the same observations and likes for the system. The users made several observations related to the design and placing a greater emphasis on font size and system colors. Regarding the evaluation of the system, we observed that users showed a greater acceptance for the animations and interactive examples than the text. Some users did not use the text because they were guided by the examples and animations. The following graph shows the user's preference regarding the way the information is displayed within the tool. A didactic tool for teaching Transmission Control Protocol (TCP) is presented in this work. In our proposed didactic tool, we have learned that visual aspects are very important. The inclusion of little text helps the users to have more taste and easy for learning of a subject. Our tool tries to be a complementary tool during the teaching process about TCP. Likewise, our tool can help to the students to clarify doubts related to TCP. Our didactic tool is easily accessible. It can be consulted within classrooms, at home, or anywhere with internet access. Our didactic tool can be extended in different aspects. For example, we can add more animations, more extensive example, new evaluation questionnaires, or aspects related to usability can be considered. An open access version for teachers or students could improve this tool with feedback or collaboration. Finally, other TCP functions as round-trip time during the retransmission or a comparison with UDP communication protocol can be added. Thank you very much for your attention.
Dear members of the organizing committee of the conference, dear authors, after several months of works under this new condition imposed by the coronavirus, we come to the end of this conference today. The papers presented at the International Conference on Computer Science, Application in Engineering and Health Services, COMPSE 2020, showcased the latest innovation in algorithms and application research designed for optimization applications in the fields of science, computing, engineering, information technology, management, finance, health economics, and health systems. The conference that just ended showed evidence of the new state of the art, progress and challenge in the implementation of priority research were reviewed. Professor Romanova, in her lectures, The Phi-functions technique and its application in additive manufacturing, spoke about the phi-function technique as a powerful tool for the analytical description of location constraint in optimization design problems. In this conference, more than 30 papers were received at the call for the paper in the conference, and after blind peer review, 16 were accepted for presentation in the conference COMPSE 2020. Also, in the papers presented, approaches were identified to strengthen the science in research issues on engineering problems and health systems. Based on the evaluation of all papers accepted for presentation, the steering committee decided to award the recognition to the best paper entitled Modeling Nanocomposites with Ellipsoidal and Conical Inclusions using Optimized Packaging. Writing and presented by Professor Tatyana Romanova, Alexander Pankratov, Igor Livinchev, and Elena Strelnikova. Thank you to all the authors of the papers presented. Thanks also to the professor who participated in the review of the paper, and of course, thank you to the organizing committee of the conference. To all of them, thank you again, thank you very much, and we hope to see you in future editions of this conference.